Thursday, everyone. Welcome to Mastermind Academy. It's good to see you. Bengals Airlines, again, number one. It's just quiet today. Some days it's just like that. We're getting through the week. Everything is, winding down from the week for the most part. It's all good. Not a problem at all, but I hope you're doing well today. How's everyone doing? It is just quiet. What's up? CH2S for Chaos. How are you doing? I'm assuming that's Chris, maybe? T-Pain did a great job with the lobby music as usual. What's up, Nitro Sage? How are you doing? I'm doing Chris. Yeah, I figured it was Chris. Yeah, I figured it was Chris. But you had to. You can't always assume. This is gonna frustrate me. I have two mic boom arms. One in my office is completely fine. This is the more expensive one. It's supposed to be nicer, and it gets loose every day. I don't really know what happens, but it's all good. It bothers me every single time. But if it's it's my little fidget spinner, I guess. It keeps me going. But tonight we are going to be hopping into some loops and to some functions. So we're getting to this really, honestly, this really rounds out the core programming skills. Okay, it really rounds out the core of what we have to do. But the core of topics that you kind of, I always says you have to know to start to do things and to make effective pieces of software and to learn how to solve assignments, to solve problems. The GitHub assignment is due whenever. Everything is just due at by the end. Everything. I think the exams are the only thing that are timed, but they're like 2 week times. 2 weeks timed. Everything else is just due at the very end of the course, just by the last day. Is what it is and that's only because we're going to go through and do. Have the stuff that we have to do, go through and do the verification of people who completed all the stuff so that we can get you all, statements of completion and your little seal of approval and stuff like that as we are kind of going through the process of making this more and more formal, or at least the certification process of completion of the course more formal. People want the credit for it. But yeah, we're going to hop straight into it because every single night we are going longer than I would like to go. I really want to get people out of here by 9. We only have 2 concepts tonight. One of them is it takes a little time to wrap your head around, and there are a number of, and I don't want to say iterations of it. Little pun there, unintended pun, but it should be good. Weird audio issues. Let's see. What are you hearing? Maybe I'm hearing it as well. Let's see. Yeah, I'm hearing a little fluttering. Let's see. What's up, Warp 10? Yeah, hold on. Hello? Okay, what about now? Is it back to fixed? That feels like it fixed it. I think I fixed it. All by cutting the FX on and then off. Let me know if it's fixed. Yeah, there we go. Thanks for letting me know. I appreciate that. Thanks for letting me know. I will be honest, I love this Go XLR mixer. It made audio setup easy. It was actually really difficult for me beforehand, but it does run into weird settings problems like this. The FX button wasn't on, but it sounded like remnants of an effect that was on, and you cut it on and cut it off, and it's good to go. Again, super odd, really, really weird. But let's get started today. There are a few slides. I will update the slides command in a second, but let's go ahead and get started. Let's go ahead and get into Classroom and let's take a look. And you all also have, I know you just got your first GitHub assignment because it took me forever to fix it. I was able to fix the other GitHub assignment problems. And I actually need to go back and solve one of the tests for the one that I already released to you. So I'll fix those. I'll make sure to get those fixed. For people who have already submitted their answers, it'll actually, when I make a change to it, it should automatically update your repo and rerun the tests automatically. So if you've already submitted something and it is failing, which I think the third item on there is probably failing, it should fix it for you. If not, I'll do whatever I can to make sure you don't have to go in and do anything. But if you do, I'll let you all know what has to happen there. But you'll get another assignment this week, and then you'll actually start to get 2 assignments kind of coming up per week, and they'll be different to challenge you for some different things, and it won't be specifically always around what we're learning that week. We might have one little thing that really highlights that, and the other project might be a little bigger and cover all the things that we've done previous and have concepts of that all inside of it. So yeah, that's what we'll be doing. So let me make sure this is available to everybody. Copy link, exclamation point. See how I'm typing this today. Commands, edit. What was the slides? It's not great, I'll tell you that. There we go. Okay, so if you need the slides, you can hit exclamation point slides, and there we go. We got some slides here. Let me take a sip of water, and then we can get started. So today's fun. We will solve our first algorithmic problem today. We'll solve a problem. We'll read something. We're gonna dive into one exorcism problem, and then we'll just do a fizz buzz. We may do the raindrop problem on exorcism as instead of fizz buzz, since it's basically the same thing. But I want people to know about fizz buzz since it's such a cult classic and such a meme in the industry. To be honest, I want you to be familiar with it. Today's agenda is loops, functions, triangle, and fizz buzz. So those are the two things that we're tackling. Triangle and fizz buzz are almost the same thing. They're almost the same type of problem. Fizz buzz is going to present one extra thing. If we have time, I have another one that I'd like to go through. But again, realizing that we're probably not going to have time, I remove that. And so if we have time, we'll hop into it. All right, so loops. We've already touched on loops this week in the other course, and we did some stuff yesterday when we were doing our ETL process. But now we're going to spend a little more time with it and understand loops a little more dynamically. So this is where your code becomes more dynamic and you get to do some cool stuff. So what are loops? Loops are used to run a set of instructions multiple times. All right. Remember, all programming is providing the computer a set of instructions to perform a task automatically. And so if we want to run something multiple times, if we want to run things over and over again, we don't want to have to keep running that code, keep copying and pasting that code. We can use a loop to make sure that happens. There are different types of loops. And for our case today, we're gonna mainly deal with for loops because Go actually only has for loops, but that's for later. For loop is one of the types of loops, and while loops are the other type of loop. And we're about to go over what each one of those is and when to use them. Loops run for as long as a scenario in which you specify is true. Again, you think true and false, think about Boolean values. So we're going to create some scenarios like we did with those if statements, the same way we did that conditional flow. And we said, hey, if this thing is true, or this thing is true, or if this thing is true and this thing is true, or just if this thing is true, go ahead and do this. Loops are the same way. It's almost like, hey, it's almost like an if statement every time you run it. And so it checks for a value to be true or false. It evaluates the statement. And if it's true, it will run the loop and it'll run all the code that's in the loop. And then it'll start back over and see if that scenario is still true. And if that scenario is still true, it'll run it again. So it's a pretty cool way to do things. And once you wrap your head around it, it actually is pretty easy. Let me see, my glasses are extra dirty today. 1 second. All right. So there are two types of loops. Let's go while loops first. So Go does not have while loops, and we've traditionally been diving into Go first. We're going to dive into Python first for while loops. I think it's an easier walk into when you start with the while loops. So we're gonna talk about this. While loops execute code as long as the scenario which you specify is true. That is true of all loops. While loops can create infinite loops. Also true, so can for loops, but traditionally, I threw this in here because traditionally, if you want to create an infinite loop, a loop that runs forever, you may want to use, a lot of people just use while loops. If you have a while loop available to you, you can also use for loops like while loops in Go. But there are also two, they have some verbs here, they have some keywords here. The continue and the break keywords give you additional control while using a loop. So we're gonna hop straight in and see this in action. So we're gonna create a scenario. As long as that scenario is true, our loop will continue to run and loop over itself. It'll continue to run as long as that scenario is true. and I'll show you how to create infinite loops, and we'll talk about that continue and that break command. Actually, no, let's go through the slides first, and then let's go through all the slides first, and then we'll dive into some code. So when would you use a while loop? While loops are generally, and this is a general statement, but it's best to use when you aren't sure how many iterations of the loop need to take place. So when you don't know how many times this loop needs to run, that is probably when you want to use a while loop. That's not the steadfast rule. You could probably always use a while loop if you wanted to. You just have to use it in weird ways. Same thing for for loops. You can use a for loop for just about every scenario, but it just may not be ideal for what you're trying to do. What's up, Goku? How are you doing today? It's good to see you. All right, so incrementers, the famous I. So you might see I all the time, but the famous I. We can use a variable. So we know what variables are. They can save some data. We can track that to control the number of iterations to our loop, the number of times the loop runs, the number of times the code that's inside the loop is performed. And so we can use a variable to track it, and it can be anything. A lot of people use I because it's an incrementation variable. Like it's a very common thing to use. So just want you to be familiar with it, but we can use that to track this, and we can do that by tracking the number of times. We can save number data to a variable, and so we can start to track how many times something has run. We can increment the incrementer, okay? You must manually increment this variable after an iteration of a loop. So when you are using an incrementer, if you are using a variable to track how many times this loop is running, and if you're using that to determine, to help determine whether or not the scenario you've created is true or false, then you must manually update it when the loop runs. So as the code in the loop runs, you must go ahead and update that thing. And so there's some options here. There's I++, which is an incrementation expression. Whenever you see plus plus, that means add one. It means add one to something. This is not available in Python actually, but it is available in Go and most other languages. The plus plus in all these languages mean add one. The I plus equals one is one of those assignment operators we talked about, and it's going to add one to I as well. Or you can just do I equals I plus one. This is the long form version of all of it. What are your stopping criteria? If you're not sure when the loop should stop, while is great. So yes, so that's a good question on what the stopping criteria is. And so we're gonna talk about two things. One of the things is this keyword break. So maybe I created an infinite loop. Maybe I created a loop that's always gonna run, where the scenario is always gonna be true and it's gonna run forever. And we wanna figure out when to exit out of that. Maybe we're going through a gigantic list of names and we have no idea how many names are gonna be in there. There are better ways to do this, but maybe we're going through it and we wanna get out of this loop once we reach a name called Brian. And maybe Brian is like number 600 or something like that. We can use this break keyword. We can put some code to check to see, hey, are we at Brian? And if we are at Brian, we can run this break keyword to get out of the loop. That's one way. One of the other stopping criteria, again, is the scenario that you create. You can change things over time. While the loop's running, you can be updating things outside of the loop. You can be making changes to what's going on in the application. And you make it so that once you're good, once you've satisfied what you need, that you change the code so that the scenario is no longer true. And it'll make more sense when we get in here and we do this. What's up, Mercurian Thai? I tried that a bunch of times. I wanted to say Mercurial because of the version control and source control management system, but welcome. I had to do it 3 times before I got all the letters there, but how are you doing? All right, so break is that keyword to break out of the loop. If you are iterating through something, you're going through it, break will get you out of it. All right. And continue, on the other hand, you can end the iteration of a loop. So maybe you can have all the code in your program in a loop. Like you can have a bunch of code in there. It may not just be one thing, it may be a ton of code. And you can actually have something in there called continue. The continue keyword stops the current iteration of the loop, but it doesn't end the entire loop. Break stops the entire looping process. Continue does not stop the process. It moves on to the next go. It moves on to the next go. Be careful with continue. You gotta be careful with continues, especially when you're using while loops. Excuse me. And when you're using while loops or even in for loops for Python specifically. For Go, this is not so much of a problem. We'll talk about why that's not a problem. So you have break and you have continue. And yeah, this is how you create an infinite loop. We'll do this. You can do this with both a for loop and a while loop. And let's stop there for while loops. Let's actually go mess with the while loops now before moving on to the rest. And again, we're gonna hop straight into Python because Go does not actually have while loops, but the for loop does operate a similar way, but that'll be confusing. All right, let's hop on in. That's not what I wanted to do. I wanted to open up VS Code instead. All right, so this is our little ETL process with SpaceX data that we were using yesterday that we had a little fun with. Just messing around with it. Let's go ahead. That should be saved. There we go. That's weird. We're in pipelines, so let's go back into deCoded. Open this back up in a new browser. Well, new window. Close all the things that we already did before. We don't need to see all this. There's probably a close to the right. Close to right. And this one too. All right. I missed yesterday to get a COVID vaccine. You feel like you got hit by a truck, BPez? Well, one, thank you for taking one for the team. Let us know how you're feeling. Definitely let us know how you're feeling. I'm still waiting for a couple more iterations of people to go because I've heard mixed reactions just like that about some people feeling like, hey, I don't feel good after this. But other people have been completely fine. So yeah, I'm a pretty sweet 5G hotspot right now. Well, you know, we're here. Let us know if you need any help. We can send some water. You know, I got a little bit of water here. We can send it over, cool you down a little bit. But yeah, what's up, Rocadius? How are you doing today? But definitely let us know how you are. I had an arm sore for 24 hours. That's it. So yeah, I'm hearing so many mixed things about it. I don't. So interestingly enough, I'm not afraid of needles. I am not afraid of needles, getting my blood drawn, stuff like that. It's fine. It's like completely fine. I haven't gotten a shot in a long time. And I can't remember what I got it for. Maybe it was college. Like maybe I had to get a booster shot. I had to get some shot while I was an adult. And man, they put it in my arm and like, again, not afraid at all. And like, I don't know if they hit a nerve or what, but like, I feel like it shut me down for like, I was like, for like a good 30 seconds. I was like, oh no. And then like, it hurt really bad. My arm was super sore for a while. And like now I'm kind of afraid of shots, I guess, but I'm not afraid of needles. I've got my blood drawn plenty of times since then, but I don't know, man. I'm starting to feel it in my arm right now just thinking about it. I felt like a punk. I'm not gonna lie, but hey, it is what it is. I'm not afraid. I'm not afraid to admit that I didn't like that at all. I usually don't get the flu shot, to be honest. I've also, knock on wood, and this is gonna be the year that I get the flu. So I may have had the flu at the beginning of 2020. Everyone says they got sick. I'm not joking. I genuinely think I had COVID at the beginning of 2020. I think I got it on Christmas Day. I woke up on Christmas Day feeling super weird. And when I tell you, I was down and out for like 4 days. But that was it. I was only down and out for about 4 days, and I started feeling better. I was so weak. It was terrible. But like, it didn't. I had a terrible dry cough. Yeah, it was like I never felt like that in my life. But I didn't go to the emergency room or anything like that. So I don't know if it was the flu or something. But it was intense. And so I feel for people. If that was the flu, then maybe I'll start getting the flu shot because I have never felt like that in my life. Like I was so weak, like I just couldn't get up. Like every time I had to go to the bathroom, it was awful, man. Like I had to use all of my energy for everything. But yeah. Worse than when you got COVID. Yeah, I mean, I was super sick, but it went away so fast though. Like when it was done, it was done. Like I was like dead, and then it was like, all right, you're back to almost full capacity. I felt amazing. All right, So what are we on? We're still on week 3. So let's go back into week 3. And we still got Go and Python in here. All right, we're gonna start with Python. And we are going to go-r04-loops.py. Okay, let's do this. So starting with Python again, because Python has while loops and Go does not have while loops. So that's why we're starting with this. And let's take a look. I don't know why I did that. That was not what we want to do. So a while loop. A while loop uses the while keyword, okay? And so the first thing I'm going to do is set up an infinite loop for you. We're setting up a scenario. So the same way we use an if statement as kind of that keyword, we use the while keyword first, and then we set up the scenario that we want to check, the comparison operator, whatever it is that we want to check. So we could do something like, check if 5 is less than 4, something like that. Maybe if we had some variables, we could check if a variable is less than, greater than, so we could do that. But to do an infinite loop, it always runs if it's true. So we can add a Boolean here and say, while true, do this thing. And so right now I'll just do print. This is an infinite loop right here. And this is a full loop already. 100% full loop. I mean, we've already created our first piece of code. And when I go to run this, remember, it is infinite. Be careful doing infinite loop. Sometimes if you're using something, a weaker computer or something, it can cause some problems trying to get out of this infinite loop. But if you do Python and run our code, no, true is not defined. Maybe it's capital T in Python. See, I'm never gonna remember that. Capital T, there we go. Looks better. Real Boolean. And it's just running. It's running nonstop. If we look at the, let me open up a new terminal over here and watch free-m. Maybe we can probably start to see megabytes getting used up as every time it refreshes. And you can see it going up and up and up because it's putting more stuff in the RAM. It's just running nonstop. Okay, it infinitely. It'll never stop. Why? Because it'll never change. This scenario will never ever change. Let's see this real quick. What's happening is it says, hey, while true, go ahead and run this code. This is a true statement. So it's going to run this code right here. It's going to run it. Then imagine this. Once this code is executed, it's successfully completed everything that it needed to do. And what it does is it goes right back up here and it checks this again. And then it says, cool, this is true. This statement is true. I'm going to drop back down. I'm going to run this code. Once it's done, I'm going to go back up here, check again. And this is why it is an infinite loop. It is running infinitely because this scenario it's not changing at all. So if it's true once and you don't change anything about it, you don't change anything with the program, it will continuously run. This is not the only way to create an infinite loop, but the scenario for creating an infinite loop is to have a true statement where nothing else in the code changes throughout the process. So if you don't want to have an infinite loop, you need to be thinking right now that I need to be changing things during the code that's under here, all this code that you're writing to satisfy the loop. You need to be doing something in there to change the scenario, most likely. There needs to be something happening that you can check against for you to be able to stop running this thing. All right, so that creates an infinite loop. Great, that sounds exciting. Now, you can say, let's say we have, this is Python, so this is great. So let's do input. Let's grab some user input, okay? Let's say user input equals input. What do we want to ask? We'll say, please enter a number. Let's do that. Please enter a number, and we'll turn that into a string. I mean, an integer, because remember, it comes through as a string every time by default. All right, so now we're going to enter this, and let's instead of doing a while true, instead of doing an infinite loop, let's swap this out a little bit. Let's do a little math here. Let's say let's do something fun where we're entering a number. And let's count down to 0 from whatever number this person has put in. So they're gonna put in a number, we're gonna count down to 0. So here, I'm gonna put this here so we know what we're doing. write a loop to take the users and count down to 0. Okay. And so how might we do this? So we're going to save the value of the user's input. All right. And we are going to we're going to begin a loop with it. And so we can use this user input like that incrementer. Remember we talked about that I variable, that incrementer. And that incrementer, again, is just going to be a variable used to track the runs of the function. It's going to be that thing that we can change to be able to check against. So that can really be anything. So I could change this to I to make it easier, or maybe we start with not taking user input. Maybe we just start with how to count to 10. Let's try that first. Let's just try to count to 10 first, and let's start with I so we know how many we want to do. We can start with I and we can set it equal to 0, so that we can count stuff up. And the scenario, if we want to count to 10 while I is less than 10, we want to go ahead and we want to print I. We just want to print out I. We want to see what I is every time. Okay, so this is the scenario while I is less than 10. As long as I is less than 10 is true, this code right here will run. So when it's 0, it'll say, hey, is 0 less than 10? Yes, that is a true statement. It's going to run this. So it's going to print 0. Then when it's actually, so no, let's see this. And we run this, we get another infinite loop. Okay, we get another infinite loop. It is still running. Why? Because we've done nothing to change the scenario up top. We have done absolutely nothing to change anything about the scenario. It's going to check the same scenario over and over again, and it will continue to print this out because that's what it is. So we need to write some code to change that. And so this is where the incrementer comes in, and this is where we have to add 1. So after we print, we are going to we're going to add 1. So it's going to print, then we're going to add 1. The last thing that we're going to do in the loop is to add 1 to our incrementer. So remember, we're using this to track. So that'll add 1. So after the first run, I will now be 1. And it'll say, hey, is 1 less than 10? Yes, 1 is less than 10. Go ahead and run your code. It'll print out 1. Now it'll add, I is now 1, so it'll add 1 to 1, and now I will be 2. And we'll go back up, and it'll go only until, whoops, I didn't save that. All right. And now we count from 0 to 9. All right, why did it only go to 9? Does anyone know why it only went to 9? Really anomalous coincidence. Okay. Does Python run the code in the loop once, even after the condition is true? So no, it does not. That is what a do while loop will do. We're about to learn about do while loop. It will not run once automatically. It's a good question. Really good question. Does Python not have? Well, so that's what a do while loop does. I don't know if Python has a do while loop, to be honest with you, because I don't use do while loops, to be honest. I thought Python did have do while loops though, but we'll check. I don't know. But do while loops are a thing in some languages, and it allows the code to run once no matter what, which is valuable. This is a valuable paradigm. It is something that you will find helpful at times to run the loop at least one time. But yeah, let's see. All right, exactly. Yeah. So what happens is this counts all the way up to 9. When it gets to 9, when this runs, when it's 9, it says, hey, I is 9. So it says, hey, is 9 less than 10? Yeah, it is. So it's going to print out 9, which it does here. It's going to add 1, and it's going to go ahead and run the loop again. And it says, hey, let's evaluate this again. Is 10 less than 10? No, it is not less than 10. So it stops. The scenario is no longer true. So it quits out of that. And so this is where, setting the equal sign will come in. If we want to count from 0 to 10, want to count from 1 to 10, we can do the other one here. So that is the basics of a while loop. And it doesn't need to be, there's many ways to use this, but this is the most common paradigm, is setting up the incrementer right here and then going through the loop and then manually incrementing the incrementer or decrementing. Sometimes you want to count down. Sometimes, you just need to use this number to track what's going on and to change the scenario of what's going on. So we can use this to count to any number that we would like, or run through as many times as we want. So that is a while loop, and we'll practice some more iterations. Like I said, we are going to put this code into practice in a little bit with some different options. Let's actually look at the break. Let's look at this break and continue keyword really quick. Let's start to put together some of the stuff that we learned. What if we want to count here up to 10? What if we want to skip the even number? No, that's gonna take you a little too far forward. Maybe we want to skip the number 5. What if all we want to do is we do want to do this, but we want to skip the number 5, okay? But we want to skip the number 5, but we want the loop to continue, okay? So if we want to skip the number 5, we can check to see if I is 5. So when I is 5, we want to skip it and not print it out. And so we can do if I, equals 5. Okay, if it equals 5, instead of printing this out, we can continue. Otherwise, and so this is one of the paradigms where you see people not having to put else. We don't care about any other scenario. The only scenario that we care about is when I is equal to 5. All right. Once it hits continue, it will ignore the rest of the code underneath. It will immediately jump back up. So when it's looping through, if I is 5, if it hits this continue, it will immediately exit out and go to the next iteration. All right. This is going to cause some problems, and this is why I said be careful with continue, especially with while loops. Just watch what's going to happen here. All right. So theoretically, what's supposed to happen is every other time when I is not equal to 5, it'll basically not run. It'll not run this this if statement here, and it'll go down and it'll still run this print and adding 1 to it. But let's watch this go. What's up, Kush? How are you doing today? All right, check this out. Rest in peace. One more time. We hit ourselves in infinite loop one more time. This is why I immediately introduced you to infinite loops. It's very easy to get caught up in infinite loops, okay? And so what it's doing right now is it's actually in an infinite continue loop. It is hitting this, and then it's simply continuing every single time. It's just nonstop in this continue loop because I is 5. It'll never not be 5 anymore. This code is unreachable. It's unreachable now because it's stuck in this little cycle right here. So I'm gonna end it. And the way that we can fix that is to, hey, if I is 5, make sure you still increment first. Increment first, then continue, okay? So now we should get 0 through 10, but it should skip the number 5. All right, so we get 0, 1, 2, 3, 4, skips number 5, 6, 7, 8, 9, 10. So that's what continue does. Continue allows it to keep going. Continue allows the code to continue on. But if we were to change continue to break, we could break when it's 5. So let's say you didn't want to set an incrementer. Let's say you wanted to count to 100. Check this out. Let's say you wanted to count to 100 without actually using an incrementer. Well, no, you still need an incrementer, honestly. 0, but you want to do it. Let's say you wanted to count to whatever number you want to count to. You can say while true, and you can say if I is equal to 100 or 1,000. How about that? Once it gets to 1,000, that's when we'll break. So we don't need any of this other stuff. Actually, we do. We need all the rest of the stuff. So this time, it's going to be an infinite loop. This is an infinite loop, but we are using the break keyword to change the ending of this. So the loop will always evaluate to run, but we are using our own logic in here to stop it. Break stops the whole thing. So it's going to count all the way up to 1,000. It's not going to count all the way up to 1,000 because I did not save it. Even though I keep feeling like I'm hitting the keys, it didn't save it. And it got up to 999 and it did not print 1,000 because we broke it out before we printed it. This is what the break keyword does not continue like continue does. Continue says go to the next iteration. Break says, hey, in this whole thing right now, I don't care what number you're on, I don't care where you're at, get on out of here, get me out of here, and keep running the rest of the code. So it doesn't end the program, it ends the loop. So if there's any more code down here after the loop, it'll run that code, it'll move on to that code, but it does break and end out of the loop. Okay, so while loop, run while this scenario is true. And usually you have to use an incrementer to track what's going on in the list. You can use the continue keyword to go to the next iteration of the loop, like basically stop what you're doing now and go to the next iteration, or you can use break to get all the way out of it. What's up, Jack? How are you doing today? Scott, it's good to see you as well. Thank you so much for the follow. Welcome to the channel. Hope you're here ready to learn with us or ready to help us learn. We learn a lot from each other. So someone by chance ran an infinite loop. How would they stop the code from running? Oh, sorry. I feel bad about that. I keep forgetting to say this. Yes, if you have an infinite loop running, the way that you end it is Control C. Control C is how you end it, okay? Or Command, I think it's always Control C. I think even on a Mac, it's Control C and not Command C, but Control C or Command C. How did you fix the issue with continue? Great question. Let's see if we can undo. The way that we fixed it is that we have to increment before we continue. So I had to put I plus equals 1. So I had to do that incrementation. Like I want to count that we did this run. So I'm going to add 1 before I run the continue, and then it will and this will fix the problem. This bit of logic can be confusing, and this is honestly like for the most part, like this is the type of logic you are going to be fighting through for a lot of the beginning pieces of your learning. It's stuff like this, and so don't sweat it. I'm going to go through it kind of quickly, but right now the goal is to understand what a loop is. Just understand what a loop is. If you're like, hey, I don't know what the heck you're doing there, but I do understand that a loop, I can create a scenario that evaluates the true or false. It'll always evaluate the true or false. And so I can say, hey, while I is less than equal to, let's say greater than equal to 10, and let's do it. Let's combine some stuff. And while I is less than or equal to 20. All right. So maybe we only want to do it here. All right. If we did this loop would never run. This scenario says, hey, I has to be greater than 10, greater than or equal to 10, or less than or equal to 20. All right. So if we try to run this now, nothing's going to happen. Why? Because when we start this off, I is 0. It's 0. So this is never true. This statement, when it runs the first time, is not true. So it continues through and the application ends because there's no more code. If we wanted to print 10 to 20, we can put 10 in there. And we can print 10 to 20. And again, we can combine as many of these operators together using this option, this logic operator right here that we just threw in there. Did you mention about the range method? Not yet. I will mention range method shortly. All right. So that is a while loop. There's also in programming, there's do while loops. Okay, so like while loops, but they do run at least once, even if the conditional statement is false. So even if that conditional statement is false, do while loops will run. This is not a thing in Go. People are saying it's not a thing in Python. I don't know because I don't use do while loops, to be honest. Do while Python. Let's see. Okay, so people are asking how to emulate a do while loop. Not there. I think they have them in Ruby. You can do one in Bash. But yeah, they're something to know about. I want you to know about it because again, we're using these programming languages as catalysts to learn, but I want you to be familiar with these concepts. There are other languages that you'll run into that do have do while loops. If you ever run up against it. The only difference here is that it will run the iteration at least once before, regardless of the statement. And if the statement's false, it will then stop. Okay. All right, so now we're into for loops. We're gonna talk about for loops, and then we are going to dive deep into both of them, and we're gonna play around and we're gonna mess around, and we're gonna really understand what's going on with them. This one's gonna be syntactically, this is gonna be a little confusing for you, but just bear with me. So what is a for loop? It's a control flow statement, just like those if statements. Specifying iteration, which allows code to be executed repeatedly. It's a loop. No big deal. Don't need to think about anything else. It is a loop right now. it is for the following condition. Go ahead and run the following code. So for the following condition, run the following code. It's also, it's very similar to the while loop in hey, you know, make sure this thing is true and go ahead and run this hashtag Friday. The love, man, the love and support. Don't think it's I'm missing it. I appreciate it. I appreciate you, man. I really do. Again, we all need to contribute to the war on the advertisements. Thank you so much. Please thank your gifter. Please thank hashtag Friday. I'm telling you, man, we're gonna get some Warzone games going, because I need you to carry me to victory, because I'm a bum, especially because I haven't played so much in the past few weeks. I got a little more work to do. I got like 3 videos to edit this weekend. That part's gonna be a little trash, but after that, I'll actually have a little bit of time. I will. You know, I gotta get some games in before the baby comes, because you know, either the baby's gonna come and I'm gonna have 0 time for anything, or the baby's gonna come and I'm gonna be up 24 hours straight, so I'll have plenty of time for everything. Either way, you never know what's gonna happen. So I appreciate that. Thank you so much, man. All right, so for loops. Let's go ahead and use it. First, let's talk about when to use them really quick. I think it's just helpful to throw this in now. For loops are best used when you know how many iterations you want to do. So if you know how many times you need to loop through, for loops are generally, and again, I really want to stress that word, generally better for that reason. Also, when iterating over an object, think about something like going over a list, iterating through a list, iterating through a slice, you know, an array, is generally, for loops are generally work better for that. Yeah, especially if, you know, the collection is ordered to use their indices. That part, I don't think that last sentence should be in there, but it shouldn't be in there. I feel like I would have thrown that in for a reason, but yes. Okay. For each loops, this iterates over every single item in a collection, even unordered collections. Okay, and so maybe that's why I put it this for each. Maybe you don't need to know it. Maybe. Okay. But yeah, so for each thing in this collection is kind of how I want you to think about it right now. If I have a collection of things, for each is saying, hey, perform this loop, perform an iteration for all the things that are a part of this. And so this allows us to iterate over collections here. Each language implements this differently, for sure. And so we will talk about that. Does Go have a for each? Yes. Go does have it does not have, Go has range. Range in Go works differently than range in Python. And range in Go, it does the range over an iterable item. So yes, it does have a for each. Can't read any text, gift too engrossing. That's fair. So that's where range comes in. I'm not gonna talk about range quite yet. Let's hop into some for loops. We're gonna do it with Go first, and then we'll do it with Python, and then we'll kind of dive deeper into these things. So let's go to Go, and we're gonna go into Go first, because Go is going to Go has a standard syntax for loops. There is a standard syntax for loops amongst programming languages, but Python does not incorporate this, and so it might be a little hard to go from Python to this one. Yes, Omer, we talked about continue already. Yep, we did, and we'll use it again. Yep, it's right here on screen. Yep, but we'll make sure we're gonna use it some more for sure. A package manager list of packages, didn't realize it was technically different than a for loop, but it makes sense. Yeah, yep. All right, so let's see here. Let's open up a new thing here. Code. What are we on? 08, and we're gonna do for-loops.go. All right, and let's close this. So we have some space. We got package main in here, and let's get our function set up. All right, and so let's use a for loop to just count to 100. And so the way that we can do this is fairly simple. It actually makes a lot of sense once you look at it enough times. It's very hard to me. It was very difficult to memorize the syntax up front because no one broke it down to me properly. It just looks like a bunch of text all together jumbled up, and I was like, how are people remembering this? But it's pretty simple. The way that a for loop works, and if you use the I'm not going to use the built-in thing to kind of show it out, because it will it will give it to you. It'll give you the whole syntax. The second one, I'll do that. I want to break it down to you first. I want you to see it. Before, when we did the while loop, we had to manually create the variable that we were going to use to increment or to track what was going on. We had to create that up front, and then we ran the while loop, and then we updated that variable, which was, I guess, technically scope different. Here, we do it all together. The for loop in Go, we're going to do it all together. So it's broken up into 3 parts. The for loop line to set up a for loop is broken up into 3 separate pieces. It is first, you set up a variable. The very first thing you do is set up a variable. Then you set up the scenario that you want it to evaluate to be true or false. So then you set up that same scenario, and then you tell it what to do after one iteration of the loop runs. You tell it what to do after each time an iteration of the loop. So you set up a variable, you set up an iterator, you set up the scenario, then you set up what it does at the end of each thing, at the end of each run. So the way it looks is, if we want to use I as our iterator, we say I equals 0. Let's say we want to count to 100. So we say I equals 0. That is the first piece. Then we use a semicolon to separate the two. Now we're going to do, we want to count to 100, we're going to say, as long as I is less than or equal to 100. All right, as long as it's less than or equal to 100, we can do something. And we've been printing stuff out. We want to count to 100. So we'll print out whatever I is, as long as it's less than or equal to 100, because we're starting at 0. Then what we want to do at the end of each run is to add 1 to I. So then I'm going to put I++ here. This is the standard syntax for a for loop right here. This is the same thing you can do in JavaScript. This is the same thing you can do and just about everything else except for Python, to be honest. No, it's not everything, but this is a standard for loop syntax. You'll see this elsewhere as well. So again, maybe I'll put this maybe I'll label this really quick and put it in the classroom. This is to declare iterator. Then the second piece is the evaluation statement. And so that's true or false. And then the last piece is the incrementer. Increment, I don't know. Sure. And this is what happens after each run. Okay, that is the kind of breakdown of what happens here. Okay, so I'll make sure to not remove this so I can put it in there. So now the code that we want it to run when this is true is right now we're just going to go ahead and we are going to print out I. Okay, so there we go. That's our code for our first Go for loop, and let's go ahead and run it. Go run 08 loops.go. Takes a little bit to compile, and you can see here it counts from 0 all the way up to 100, and we get that. So what's happening is it is the very first time the very first run of the loop, it is setting up I. I is actually I'm going to show you something. We haven't talked about scoping yet. We're about to talk about functions in a little bit, and so I can talk about scope a little bit, but I'm going to show you something really quick before we get there. The first time it sets up I as 0, and then it says, hey, is I less than or equal to 100? Yes, it is. Let me go ahead and run that code. And so it runs that print statement. When it's done running that print statement, it says, hey, I'm at the end of this loop. Now what do? I increment I add 1 to I right here. And then so now I is 1 after the first time. And then it's 1, then it's 2, then it's 3, then it's 4, then it's 5, then it's 6, all the way up. And again, this is what happens at the end every time. This is really nice. In the scenario that we did before, where we wanted to skip 5, a continue, I believe, would work fine here without having to put the incrementation in. Let's say we wanted to do this to count to 10 and skip 5 like we did before. And we want to say, hey, if I is equal to 5, go ahead and skip that thing. And so we could just say continue here. And it would still, this should still properly work. This should not put us in the infinite loop. And it says 0, 1, 2, 3, 4, 6. The reason why it doesn't is because this for loop, you're handling the incrementation in the place where you're declaring the loop. So even when you hit that continue, the continue says, hey, I'm done. I'm done with this run, move on to the next one. So the incrementation still happens. There's still one added to I. So that's why it differs from the other one. It's a little bit more difficult to create that infinite loop in this manner because there's something in this for loop, there's basically something changing all the time. Now you can create an infinite loop in Go with these for loops as well. You can just do 4. And so let's say, I'll just do it. Undefined I, that makes sense. And let's just create I up here anyway, so that it can at least give us some output so we know it's doing something. And it will continuously do whatever because it is just writing 4 with no scenario. Basically, it's going to default to true every single time. So you can still use this for loop to create an infinite loop if you need to do it. You do still have the continue keywords and you still do have the break keywords here. So actually, oh, this because we're not incrementing at all. Let's do, no, whatever. You can still do the continue. You can still do the break keywords here as well. So I'm gonna actually back that on up, back to how it was. Cool, there we go. So this is a for loop. Any questions about this? For I equals 0, while I is less than 1, I plus plus, and then decrement. That's also, yes, that will also give you an infinite loop. Actually, oh, hold on. Well, that'll give you 0 every time. Interesting. Okay, that's yeah, that's fun. That's nice. So amazing. Second billing cycle. We will add 1 at the end of each time. It'll keep it right. It'll keep it right there at 0. We'll take 1 from I, then we'll add 1 right to I. But I feel like in Go, I see. I feel like in Go, I don't think that'll work. Will that work? Now I gotta find out. Let's do. I don't think we can call an expression just like this. And even if you do 1, let's see. Okay, it does do it. Never mind. I was gonna see. For some reason, I just feel like you couldn't call expression in line like that. And I'm trying to figure out what that scenario was that I created that I couldn't do it. It was so weird to me. I couldn't figure it out, and I can't. Oh well, phenomenal. Save this. Let's fix it so that this counts to more than just 1. Let's put it back to 100. All right. What's up, Gary? Gary UK. Welcome to the channel. Good to have you. Okay, so that is what a for loop looks like. And again, there are a number of scenarios in here. We're about to talk about range really quick. Let me show you what a for loop looks like in Python really quick, okay? So realistically, you know what? I never even thought about this. Realistically, Python only has and let's look at W3 schools. Python only has really just for each, or it has to be, or you have to do it via a range. All right. I never really thought about this, to be honest. Hold on. Let's see. W3 schools. W3 schools, Python loops. Let's check this. Prime, thank you so much for the sub. You're on that 9-month streak. It's good to have you. Shout out to the Primogen. We just headed over there yesterday to watch you do some cool Vim stuff. Let me give you. Let me see if I can, type it out right. There we go. That was the fastest I've ever done it, and I typed it in wrong because I forgot the SO, like I always forget to do, because there's so much pressure when people come in and I'm like, I didn't get it, get it going. And yeah, there we go. So welcome. Good to have you. You're correct. It's an intentional decision by Guido to make loops always for each. Yeah, very interesting. It's funny because I never even really thought about that because I love the paradigm of the for loop in Go. I really like that they keep it simple with a singular loop item. I was like, oh, now that I'm thinking about it, Python's loops are always for each. So like we don't have, like I told you, Python doesn't have this same function, or not function, a loop signature. You can't do this in Python, but you can do it in something like JavaScript if you need to. But we don't have this, so we have to either use. We can iterate over a number of things. So Python has a range function, and I do have this in here. The range function in Python works differently than the range function in Go, and I think that's what we should talk about next. So for loops, home on the range. So the range function allows you to iterate over a sequence of numbers. This is specific to Python, okay? This is specific to Python, that the range function allows you to iterate over a sequence of numbers. This is not the same. Range works a little differently in Go, but you can give a function a range of numbers to sequence over. So the limit number is non-inclusive. I'll show you what that means in a second, and you can skip numbers. So range allows us to do something like this. We've been counting to 100 the hard way for Go. I mean for this. So using a for loop in Python, if we want to count to 100, we could say for I in range, and range is going to iterate over some numbers, but it takes in two things or three things, up to three things. Excuse me. It takes what number you want to start at, what number you want to stop at, and that number that you stop at. Notice in there when I said non-inclusive, I said it's a non-inclusive space. It is not. It won't go up to that last number. It is it's not an equals to. So it'll go from, let's say, 0 to 100. If we did say 0 to 100, it would go up to 100, but not including 100. So it would really only print out to 99. The last thing is a step. You can add something called a step, and you can add a number and say, hey, maybe I want to count by twos, and this will set what that step's going to be for you, for what numbers it skips and how fast it goes, up to that thing. So this is what a for loop looks like, and we can just do print out I, and this way we can count to 99 and not 100, but it's all good. I already knew where I was, and let's run this really quick. Invalid. What's the range syntax for I in? For I in range. Sorry. There we go. So counts to 99. And again, this is a for each loop. It's for I in. It's going over everything in that iterable collection of numbers for range. Let's see. You can do it with the enumerate method. Yep, you can use the enumerate method. Play for a loop, not a for each loop. How would you do? Yeah, exactly. Yep. Cool. So this is how range works, but this is kind of how for each works. So if we had a collection, we talked about those collections. Let's say we had a list in Python. Let's say we had our list, and it was equal to some text and some strings and maybe some colors. Maybe we say blue, and maybe we say red, and maybe we say yellow. All right, great. We can iterate over this through using the range function. Kinda. It does not work the same. Range in Go, range will take both ranges do take an iterable item, but specifically in Python, the range takes it takes iteration over numbers. So that's what needs to be passed in and by step. In Go, we can iterate directly over this using using the range function. But so this one will work. This would work a little different because we have to pass in a number in here. But we could do some fancy stuff in here. Oh, am I intruding a private class? No, you are not intruding a private class. This is completely open to everyone. There is a Google Classroom for these things. If you want, if you do exclamation point register, you can. It's completely free to get the stuff sent to your email, and you can do whatever. Nope, absolutely not. Let's see. What was I doing? I was doing range. So I can't pass in like our list. I can't pass this in, this will fail. Because range here needs an integer, it needs a number, okay? And so what we can do to make that a number, if we want to range over the amount of items that's in this list, how do we know how many items are in that list? Well, we can find out how many things are in this list, and we can use the length function to find out how many things there are and pass that number in instead. And when we run it, it'll, so it did not print out what we wanted, but it did print out 0, 1, and 2. It's iterating over some numbers, which means I is also a number. It's also an integer. But using those integers, we can access the things that are here. So these are, these have indices, and we can use those indices to match things. 0 is the first item, 1 is the second item, 2 is the third item. And so we can call those exact things and say something like if we want to print these out, we could say our list. What is going on here? Our list. And in here we would put our I. So this will use the indice there. Sorry, something caught my eye. And now it'll print this out instead. Right here. So the length of the list starts at 1, but you can do -1 to start at 0, 8. I don't know what that means. Oh, or is that a smile? That's to start at 0. Smile. Yes, there we go. I caught it. I caught it. I definitely caught it. Sometimes I'm not. Sometimes you're just not the sharpest knife in the drawer. But then you catch up. You definitely catch up. But yes, these off by 1 errors. I'll show you some off by 1s really soon. How was the movie yesterday? No, I did not watch it. I did not watch it because I fell asleep in my chair. Sometimes it happens. and again, this is not, I want to be very clear, because people keep reaching out with concern sometimes. Hey, I feel like you've been streaming 6 days a week. You're working super hard. Yes, 100% I am. I did not fall asleep in my chair because I am overworked and stressed out at all. I fell asleep in my chair because it was late and because I ate a hearty meal and I got the itis, and then I fell asleep while I was doing some work. So I did not get to watch my movie. So, I only fell asleep for like a couple minutes, and then I was like, okay, we're not gonna do this tonight. We're gonna go to bed and be good to go. But it is what it is. So for I range, yeah. So this will print it out here, and this is a for each kinda. We can also just iterate through this thing not using range. We can iterate through this list instead, not using numbers. And I could say for I in our list. This is for each. So for each item in this thing, go ahead and do this, but we just access it a little differently here. And so this, this still works exactly the same as it did before, but I wanted to clearly show you that range in Python was using numbers here. It was using numbers rather than anything else. So any type of collection in Python, we can iterate using, for I in, this is our for each loop right here. Now let's look at ranges. Yes, lists are mutable. Lists are mutable. Let's see. Let's do this and go really quick. Let's do a range here instead. And so this works a little differently. So let's actually, this actually iterates over the actual thing rather than those through some numbers. And so we can do the same thing. We can make some colors and we can set that equal to a slice of string. We're going back and forth, so I got to make sure that I'm thinking properly. And we go yellow, comma, and yellow's red. Yellow's spelled incorrectly, but it's still spelled phonetically, so we're just gonna leave it. Not a big deal. Green and blue. We could have done a little bit of Roy G. Biv here if we wanted, but no big deal. And instead of doing our loop signature like this, we can just say for. Okay, so this is a little bit interesting. We're not gonna dive too deep into this yet because we're not here and go yet. But I'm gonna put a comma here, okay? I'm gonna put an underscore and a comma, and then I'm gonna put I. All right. And I'm gonna do range, and I'm gonna do range of colors. So let me break down what's happening here really quick to you. I want you to see it run. and then I'm gonna break down what's happening to you. That actually, I messed up here. See, y'all got me going in between these languages, and sometimes syntactically you do things wrong. So let's go into Go and go run 08 loops.go, and it prints out those things. Let's talk about what's there. So the thing here is that range in this case in Golang, range actually is returning, it returns two values. It returns two different values here. It could be an error, so functions, period. We're about to learn about functions. We haven't learned about them yet. This is next, in like 10 minutes, we're gonna learn about functions. But range is actually, we're creating these variables. Range, you can create more than one variable by putting an I in between. Maybe this is something I should have shown you before. I could create a variable like this. I could say, hey, X, I want to set up two variables called X and Y and set them equal to 10 and 20. I could do this. So it'll set X equal to 10 and Y equal to 20. You can do this in Python as well. All right. That is what I'm doing here. You haven't seen that before, but that's what I'm actually doing here. The first placeholder, so the underscore is just a placeholder. It's basically saying, hey, I actually don't want to save this thing. Like, I know something is probably going to come back, or it's possible that something will come back. I'm just going to have a placeholder, kind of send it into the abyss, kind of send it into, just send it into the abyss. Don't really save it to anything. And so that's a placeholder there. And I is the second item that I'm setting a value to. And this range function will actually give me back it'll give me back those two values, one being an error, one being my actual value. And it is going to go through and it's going to run. Is underscore a real variable, like treated that way? But it's actually, that's actually a good question. I don't think so. I don't think it's actually a real variable. I think it's there specifically for that. I don't think, I've never seen anyone do anything else with it. I'm pretty sure it's just sent to the abyss, because if you wanted to, you might say in your head right now, you might be saying, hey, well, why don't I just throw in a random variable in there just to save it to, like, it's not a big deal, because a compiled language like this will not even, it won't allow you to compile the code if you don't do something with that variable. So if I were to save it to like Y or throw out to variable or something like that, I would need to use it somewhere. I would have to use it somewhere. And I'm pretty sure the underscore paradigm is for exactly this, to just send something into the abyss like that. All right, so that's kind of how a for loop, a range works. So this is how a for each works in Go. This is essentially, this is your for each. So for everything that's in colors, you can go ahead and do this. I was so frustrated. I was so frustrated when I found out about this paradigm, because when I first learned Go, I went to this Go workshop, this Go Bridge workshop. It was amazing. It was actually an amazing workshop. But as soon as I heard the words Go only has a for loop, like that's the only loop it has, like that's all you need is a for loop, I just assumed you had to use a for loop. So for me, if you want to iterate, so you can iterate over this without using the range function. And for a long time, I would do that all the time, because again, these are indices, these are indices, and I can do those things, but things like maps are not. And I didn't even find out about this until I tried to iterate over a map later on. Who led the workshop? Was it virtual? No, this was in person. This was years ago. This is actually what got me into Go. I only went to the workshop. I had no interest in learning Go. At the time, I was deep into my infrastructure. I was like AWS, everything, all this other stuff. And I only went because a couple other friends who were learning how to code decided to go. It was completely free, and it was at Under Armour. The dude who taught it, his name is Johnny Borsico, and he has, I think I shared it already, but I'll definitely share it again. The dude knows, he's amazing at Go. He does trainings and stuff, but he has a Go course, which I'm going to recommend to you a little bit further along, which is called a standard Go standard library solutions. The Go standard library is pretty robust, and the Go standard library solutions teach you how to it teaches you what the heck is even available to you, and how you solve a lot of common problems using things that exist right in the standard library. It's pretty dope. Now he's super dope. Like I love that guy. I talk to him he's in the Baltimore area as well, so I talk to him pretty often. But yeah, no, he's pretty dope. He's also been on the stream before. He's also been on some of our some of our panels that we have. So yeah. Oh yeah, he also hosts a Go Time podcast, 100%. Yep. But yeah, he hosted it. He's who got me into Go. And I wish I showed you. I'm gonna show you guys. I'm gonna take a picture of my laptop tomorrow and post it. I told you this year. I've already started. Getting much deeper into Go. Also, someone who may be helping out with the channel soon. Still trying to work it out. Also is a big time Go person as well. Might help out with more of the software stuff here, on here. So, you know, we love Go. We don't only love Go, but I think Go is really good for these use cases. This underscore thing is going to take me a couple days to sink in. Rockadius, 100%. What 200%. Absolutely. It can be a confusing paradigm. It might make a little more sense in a little bit when we do functions. I think it might make a little more sense. There's no generics in Go. Correct. There are no generics in Go, but I'm hearing it might be on the roadmap now. I don't know. What's the idea of the placeholder again? Again, the placeholder is because when you write, the placeholder right now, I'm gonna try this in the simplest way possible. The placeholder is here because in Go, things like errors, you have to explicitly handle things like errors. We'll get there. That's like the last week or second to last week. So the problem is if there is an error in your program, errors are a different data type. They're a different piece of data and they're handled a little bit differently. And so when you have a tool, when you have a function like range, it's possible that it can, it's possible that everything can work just fine, but it's also possible that you can get an error. And if that error is handled properly, a function has to give back, a function that uses errors has to give back two values. It returns two values because if you declare something, you got to use it. So if there's a space for errors and for you to hold on to errors, you got to do something with it because that's the way Go works. So a lot of these functions give back two pieces of information. They give you back the actual value if things work, or they give you back an error, or they give them both back to you. One might be empty. One's going to be empty. One's going to be good to go. The problem is if I remove this, I'm going to remove this underscore really quick. This placeholder is there to catch a variable. Actually, I need to delete this line. It's there to catch that error, basically. Oh, actually, I didn't think that was going to work. That shouldn't have, I don't think that should have, that didn't used to work. But, so functions that return two different things, you have to catch them both. You have to catch the things that are returned. The problem is if we catch the error and it's empty, we don't, we have to use it. In a compiled language like Go, you got to use it. You can't declare something like this and then not use it. And so the underscore kind of just, rather than saving it to a variable, saving it in a memory address space somewhere on the computer, it just kind of throws it away. It just kind of throws it away. Python, I don't know if there's a way to do this in Python. Python, you don't have to do it because the things will still run. I'm sure that there's a, I'm not sure, but I would bet that there's a paradigm for collecting things that you don't want to collect, but I don't know of it offhand. I definitely know of it offhand. It looks like the return value of a range function has two values. Yep, the first return value is the current index, and the second value, the second is the value of the index. So yeah, this could work if we wanted to do, so we could also do this. Okay, I actually thought it was returning an error. I probably should have looked at the function, but that is commonly how it's done when people are using the underscores. Right now, I don't need the index that we're on right now or the current iteration. So let's say we make this Z right here. And if I print Z, it's gonna be numbers instead. And so see here, we get 0 red, 1 green, 2 blue. That is the index. And so I should have looked up documentation for what range was actually returning. Just assumed it was an error. I don't know. But yeah. But we're not using that index, so we're kind of catching it. The problem is if we collect this to Z and don't use it, it's going to be a problem. But I'm actually really surprised that it doesn't give me an error when I don't save that index. But so like, see, if I don't do the underscore here, it'll give me that. But God, this is actually really weird to me. I feel like this definitely used to not work. Oh, can I print the underscore? Yeah, I'll print it out for you. Let's print it. That's a good idea. Let's see what happens if we try to print it. I've never printed it before, so I'm gonna do it after the loop. And let's just go ahead and format that print line. And we'll go ahead and print out just an underscore. And it seems valid. It seems like valid. Oh, I didn't save it yet. It seems valid. Oh no, it doesn't like that at all. And let's see what the error is. Cannot use underscore as a value. And so if I put it in quotes, obviously it'll print out because now it'll be a string. But no, you can't. You can't actually print it out. Again, it is. And let's see exactly what it's underscore and go. Let's see if it's only used for that blank identifier. Yeah, anonymous placeholder. And declaration, but it does not introduce a binding. So it won't bind any value to it. It won't set aside any space in memory for the value of this thing. It just spits it out. And so it looks like it's interesting because, I don't know, this is go. But yeah, so this is usually a big use case for it. Again, errors, it's used a ton, but yeah. So it's like a variable that isn't a variable. It's just temporary loops. No, so it's not just for loops. It is for, we're about to get into functions. It might help when we do that. It's available to you wherever. It doesn't just need to be in loops. But yes, it's a placeholder for a variable, but it doesn't actually save anything. So it's kind of, yeah, it's just a placeholder for what would be a variable, but that we don't want to use. And again, it kind of needs to be there because there are scenarios in which you have functions that are trying to return you multiple values, and you don't always need those values, or the values may not be useful to you. And if you return them both, you have to capture them both. So that will the underscore will allow you to kind of capture the thing, but not actually use it, because the compiler will make you use anything that's declared. You got to use it. So yeah. And so in Python, I don't know if there's an underscore like thing, but you can save. In Python, it's okay to capture to something because the interpreter will be fine. Yes, Python, you can return multiple values from a function, and we're about to do that now, actually. So yeah, these are great questions. These are the questions I love. Keep asking them. Keep asking them. Hopefully, we'll get closer and closer to a more concise, a more clear answer. But these are really, really good questions. All right, so let's hop into functions really quick. Functions are actually functions surprisingly are pretty simple conceptually. Getting comfortable using them is a different story, but conceptually they're pretty simple. It's a block of code that only runs when it's called. So even if you were to, whether it's compiled language, so a compiled language is not going to allow you to create a function that you never call. So that's a different thing. But for Python, if you were an interpreted language, if you were to create a function and never actually call it, the interpreter would go through and it would see that code. It would see that it is there, but it wouldn't execute any of it, and so nothing would ever happen. So it only runs when it is called upon. You can also pass data into it, known as arguments or parameters, and you can pass data into a function. All right, so you can pass things into it to be processed. And then a function can return data as well. So really, right now, think about functions as a little box of code. Like, think about it as a little reusable box of code. Okay, and I really need to put reusable in there so that you know that that's one of the main pieces of it. It's a reusable little box of code. Okay, and it's kind of contained. And what it can do is you can call on it. You can say, hey, let's go ahead and give me this box of code. And I'm gonna put some stuff in the box. I'm gonna pass some stuff in the box. I'm gonna shake it up a little bit. It's gonna do the processing, and then I'm gonna open it up and I'm gonna get stuff out of it. That is really what you want to, kind of what you're doing. And it's really all programming is across the board. It is it's supplying input, processing that input, and supplying output. Now, input's not required. Output's not. None of it's required. Input's not required. Output's not required. But yeah, input's not required. Output's not required. But it's available to you a lot of the time. Okay. But yes, basically like the format, the FUMP stuff that we've been doing. These are all functions, and let's look at that really quick. This might shed some light on it a little bit. In Go, we use the func keyword to define or declare a function. Okay. In Python, we use def instead. Ruby, I think, also uses def, maybe, or maybe someone, I don't remember. In Ruby, other languages, JavaScript is the whole word function is to declare. So different keywords to do it. But for the most part, the function signature, which I'm going to show you, which is similar to that first line of the for loop, it sets up how the function works, and we'll see. Yep, Ruby uses def as well. Swift uses func as well. Yep, so across the board, mostly the same. And once you understand the concept of a function in one language, you'll understand what it does in another language as well. The way that you set it up might be a little bit different, but here we go. When you see parentheses, think function, okay? That is what denotes a function. That's also denotes what calling a function is. Whenever you see parentheses, you should be thinking function, all right? How do we call a function? We said it only runs when it's called, a little reusable piece of code that only runs when called. Functions are called by name. So we call them by name in those parentheses. So we will set up a function, we'll give it a name, and when we want to use it, we will just simply type its name in with the parentheses, and that will call our function, okay? That's calling a function. It's invoking our function. It's making our function run. And it's making one iteration of our function run. We can do it many times if you want, and I'll show you that in a second. Let's do that first, and then we'll talk about arguments. All right, so let's do a function in both languages, a very simple function in both languages really quick. We'll leave these alone. We'll do it in Go first. Vim 09 dash functions that go. Not Vim. I'm so used to doing Vim. Let's do code-r. Open it up in here. Yeah, yep, y'all got it. Yep, correct. The print line would be the function. We'll get into a little bit deeper stuff on that. Those are actually called methods, but they are functions. Methods are simply functions. But yes, those are functions. You're correct. All right, so package. Whoa. Come on, don't do that to me here. Package, main. Func, main. All right, so check that out first off. The entry point to your code, remember we said this main function is the entry point to the code. This is a function. This is a function signature. We write the keyword func, then we give it a name. Once we give it a name, we put these two parentheses here. So give it a name, put two parentheses, and then all the code that's going to be encapsulated in that function is going to be done in this piece here. Okay, let's make our own other function. So that function main has to be there. Let's make our own function. What's up? What's that? Shank Rimish. I did my best there. I really gotta make my my scaling larger because it's really small and my glasses are like, I've had these glasses for like 4 years. What you're seeing on them is not, so yeah, it might be a little bit dirty, but like they're actually scratched. They have like significant like scratched up pads in the middle of both lenses. And I've just been too lazy to get out there and get some new glasses. All right, so let's make our own real quick. And we're gonna make a function that's simply called say hello. That's all our function is gonna do, okay? This function is completely separate from our main function. Main function down here, this is up here. You might say, hey, I thought a function only ran when called. How does the main function get called? Well, that's kind of how these compiled languages work. By default, that main function is called at the start of your code during compile time. So this func say hello, here we go. The parentheses here, if we wanted to pass something in, and we're gonna talk about those arguments in a second, we will put those in here. But right now, we're not gonna do that. We're just gonna simply create a basic function and we're gonna put some code in here. The same way that we've been doing things. And we can do format dot print line. And again, we're just gonna say hello. Our function is it's going to literally say hello. That's all it's going to do. And right now, this code wouldn't run. It wouldn't run because we haven't done anything with it, it would actually fail during compile because we're not using this thing right now. But how do you call it? Let's call this function. So we know that the main function runs every time. So whatever's in here is going to run every single time. But let's go ahead and learn how to call it. The way that we call it is by name. So we're going to type in say hello. And so if we type in say hello like this, it will not work. We have to call say hello with these parentheses that say, hey, call the function say hello. So what happens is when the code gets kicked off, none of this will run. None of that matters here, but it'll get here and it'll say, cool, that says call the say hello function. And so it'll go up here and it'll call the say hello function and it'll run what's in here and it'll run say hello. And that is how we can print out say hello. So let's see that in action. Let's go run this. 09. And it says hello for us. So we called this thing. I want you to also see that we can call it a bunch of different times as well. And it calls it a bunch of different times. Again, it is a reusable piece of code. It's a reusable piece of code. And you might say, oh, why wouldn't you just use a loop? Yeah, the paradigm in which I'm showing you now would probably be better for a loop, but we are, this was just to show you that it's different. Also, each iteration of this is a whole new running of this code. It's a whole new little instance of this running code. And I'm gonna show you how that works in a little bit when we get to, when we add in arguments. But that is how we would call a function here. So it's a pretty simple process. You give it a name, you write your code inside of it, and whenever you want to run that code, you call on it. That's all I need you to know right now. It's going to get a lot harder right now when we go into adding in our arguments. Is there a reason that the basic class or whatever, such as FUMT, has to be imported? Yes, frequency hop. This is so it has to be imported because we are printing something out. If we weren't printing something out, we wouldn't need to. The way that Go does its writer to standard output is using this FUMT package. This FUMT package is actually part of Go standard library. I know it seems like we're importing some kind of special tool. It's actually a part of the standard library, but you have to import most of the pieces so that your code can be kind of as efficient as possible. You're only kind of given what you need, and you have to pull in the other pieces of the standard libraries to be able to operate with what you want. So pulling in this package allows us to print out to the console. So that's why we have to do that. Okay, so that's how we do it there. Let's go ahead and do it in Python really quickly. No. Oh, I spelled Python wrong. That's why I couldn't see the into it. 5, what are we doing? We are doing functions. And a function in Python, pretty simple. Def, we'll do the same thing. Def, say hello. And we'll follow the same, we'll follow Python's rules, and we'll try to do snake case here. Python say hello, looks exactly the same. All right. Feels, so far, different keyword. So we use def instead. For the most part, it looks very similar to this def, this function right here, say hello. Now, Python is white space. White space is how it does the scoping and formatting. And so we just do a little, a colon here and then hit enter. And so this indent is going to be where we write our code, and we can print hello. All right. And so there's no main function here because the interpreter will go line by line and interpret this code. So how do we invoke this thing? All we got to do is call it. Same thing. We say hello, parentheses, and that calls this code. I want you to be clear. If I don't have this, this is valid Python code. This is legal Python code. But if I were to run this just like this, we get no output. And that's not because it didn't work. It's simply because we did not call on that function. What's up, Goudini? Good to have you, Blaze. Good to have you in here as well. It's good to see you both. Welcome. I'm actually wondering the same thing as frequency hop. Let's see, what does frequency hop ask? Let me go back up. Why does Go not automatically import packages like FUMT for you? Python has built-in functions. So this has to do with efficiency and performance, more so than anything. Because we are compiling out to an executable, unlike Python, where it's kind of generally being interpreted. It allows the code to be more efficient by not including things that aren't there. Also, yeah, that's the general reasoning behind this is that you only need to use what you want to use. So although it comes along with a standard library, although it comes along with Go, it is not a part of your main compile packages because like performance kind of matters here, and so it helps. Because Go is used more servers, its print will be in that server, which mostly you won't need to print. That's also true. That's also good. That's good input in that print, like being able to print to like, this is a common thing for all of us to do, but like there are a lot of applications that wouldn't handle this way. There are other ways to implement loggers and things that you can do. There's so many different ways to do some stuff. But yeah, I mean, it's simply because it has a lot to do with performance and need for what you're trying to do, for sure. It won't actually import the package Fred into the binary. So yeah, correct. So print is just something that's automatically available to you, Python. But yeah, it's not importing the package. That's just part of kind of the standard functions that are given to you in the Python runtime. But yeah, yep. Okay, so functions. You are awesome. If that's to me, I appreciate it. If it's to someone else, I agree. Whoever that's to is awesome. I'm gonna thank you for them, or I'm gonna thank you for myself. I appreciate that. What's up, Giannis? Okay, so that was a function in Python. Pretty simple. You know, we never called it, so let's just call it just to make sure, you know, it's gonna run how we want to run it. And again, you must use those parentheses to call it. And it does in fact run hello. We can call it as many times as we want. Now, what we want to do is we want to functions are like they're like the biggest thing. That's like basically all you're going to be doing is writing functions, and again, taking in input, processing that input in the functions, putting output, almost exactly like the ETL process that we wrote yesterday, to be honest. That's kind of how all this works, and that's what we're going to talk about. Arguments. Okay, arguments or parameters. This is when you pass information in to your function. So when you are calling the function to run, you're gonna give it some data, okay? You're gonna give it some information, and these things that are passed in are called arguments. You can pass in multiple arguments by separating them with a comma. However many arguments are in the function, so however many you define in the function signature, when you are declaring that function, and you say, hey, this function is gonna take in 4 arguments. Those 4 arguments must be passed in when you run the function. They got to be, or have to be passed in. So you need to be very clear about that. However many you set up for the function to use, you got to use all of them. What's up, Chris? How are you doing today? Welcome to the channel. Good to have you. Yeah, Power Rangers, they are having a serious argument. First off, Power Rangers was also my life. Pokemon was my life. Power Rangers was my life before Pokemon, to be honest with you, and it was phenomenal. And I love the time. And you know, when the Green Ranger, you know, started going bad, White Ranger, all that other stuff, like, man, that really rocked my world. You know, at the time, it really felt like this was the most important thing on the planet. You know, but you know, Power Rangers was great. I didn't get into all the new stuff. Power Rangers movie is amazing. The one with Ivan Ooze. I watched it relatively recently, and it does not hold up at all, but it's still amazing, no matter what. Phenomenal. Let's see. I agree with you, Frequency. Well, so I kind of agree with you, Frequency. It is such a basic thing, but I think it also has to do with the funk package has a lot of other things in it besides print. It has a lot of other tools as well. So you know, it's not tiny, but that's not the biggest thing either. I'm good. I'm good. I hope you're doing great as well. Can't complain at all. A little bit tired, a little bit hungry, you know, but after this, I'm gonna get some food, get a little bit of rest, do some work, have a good time. The baddies are always the most interesting. I agree. All right. I mean, my dad took me to Power Rangers movie. I don't remember who I got to take me to Power Rangers movie, but I know I enjoyed the heck out of it. I do remember I begged my mom to take me to the first Pokemon movie, And she kept telling me no because I had been bad. I think I was being bad, and she told me no for a long time. But I was getting good grades. I wasn't being bad. I was being bad. Okay, I was being bad, but I was getting good grades. Because I got good grades, she came and picked me up early on a Friday, like when it came out. She came and picked me up early, as so did like 20 other parents. That's how you know the power of Pokemon was amazing. Like 20 other parents came to pick them up, and we like I remember seeing them there. Like we all didn't go together, and we went and saw the Pokemon movie, which wrecked me. Oh man, I'll never forget that. I'll never ever forget that. I was in there wrecked, and my mom was like, I know she was just looking at me like, boy, get yourself together. I was hurt in that movie. That was the most emotional thing I had experienced in my life at the time. At least it was the most traumatic for sure. Maybe not the most emotional, but for sure the most traumatic at the time. Oh my gosh, I thought, it took me through a roller coaster there, man. Ooh, but good times, turned me into the person that I am today. All right. So arguments, let's pass some arguments into these functions. So the arguments we have here, these things that we want to pass in. So in Go, this is going to work a little differently. So let's actually change this a little bit, and let's call this, instead of say hello, I think we did an example of this. Let's make it an add function. So it's the function that's going to add two numbers together, and it needs to take in something. So how do you take in something? That's what the parentheses are for, okay? The parentheses are here for you to, pass in data. And so I'm going to say, hey, I want to pass in two numbers. So I'm going to say num1, which is an integer, and num2. So I want to add two things together, which is an integer. Now you might be looking at that like, what in the world? How do you choose num1 and then num2? What's the int? So the first thing here is just a place. It's a variable. You are declaring a variable, and this variable is going to be used inside of this function down here. So it's just a variable for whatever you pass in. So this is just a placeholder. Imagine num1 and num2 as a placeholder. So num1 is going to be the first thing I pass in, and because Go is statically typed, we have to tell it what type this thing is. So we have to be explicit about what type this thing is. So we're going to say, hey, we're going to pass in one item that's an integer separated by comma, and then we're going to say we're going to pass in a second item that is an integer, okay? And so now when I pass those things in, I can refer to them now using these variables. So if we want to add two things together, I'm going to format.println num1 plus num2. So it's going to do some math. It's going to take those numbers in. I'm going to pass it in here, and it's going to take those two numbers. It's going to add them together and print that value out. Okay. Now, how do we pass this data in? So we're passing arguments in. How do we, what in the world? What? Get out of here. Okay. The way that we do it is we still call add via these parentheses, but we put these things in parentheses here. So we're going to pass them in via parentheses as well. So if we want to pass in 5, comma 8. All right, they must be integers. We said they're integers. They must be integers. I'm going to say, hey, I'm going to pass in 5. I'm going to pass in 8. I also only said I'm going to pass in two things. So I must pass in two things. I can't pass in 1. I can't pass in 3. I must pass in two things. And let's run this. And it adds it together just fine. So we call add. When we call add, it takes the information in parentheses, it sends it up, and it sets 5 equal to num1. So it's using this as a variable. It sets num1 to the value of 5. It sets num2 to the value of 8. Then I use these things here, and it prints it out down here, 13. And so this is a reusable function. So I can take this, and we can switch up the numbers. We can say plus 15. Plus 78 plus 809. Okay, so we can take any two numbers in here that we would like, and you can see here each time. So you might be saying, oh well, once you assign the value num1 and num2, like what's kind of happening here? Again, these variables we didn't talk about scope yet, but they're only set up in this little section of code right here, this little box of code, a little snippet of code. And so every time this runs, this is kind of getting reinitialized every single time, so they're not stepping on each other's toes or anything like that. And we can use this function over and over again. Maybe we have an application that needs to add things together multiple times, this works as well. Passing a function as an argument. Yes, Marco Dev. Marco Dev brings up a good point. So we can pass in any data type as we want. We can also pass a whole entire other function. We can pass we can create a function and we can pass another function into this thing as well if we wanted to, but we're not gonna worry about that yet. A little farther down the line. So this is how you create those arguments, and we have to pass in what we have to pass in. If we put another one here, well, first let me show you again statically typed languages. Let's say we try to pass in, a string instead of an integer. Obviously, I think we know that, hey, it says, hey, I can't use the string 5 as a type integer in an argument to add. All right, tells you exactly what's wrong because I cannot use this thing where we are going. And go, which one is used? Call by value or call by value or call. I don't understand your question. I don't know what that means. Yeah, I don't know what that means. Call by value or call by value. Nope. I don't got it. Are those parameters actually technically variables? They yes, they are. They're variables here. They're variables. The same way that if we created a random variable, it would show us the kind of value like this. They're variables, but they're not global variables. They're variables that are scoped only to this function, and really to running this function. Let's see. I'm taking programming logic and design this semester. I'm pretty sure this is our first lab, but it's C++. Oh, dope. Dope. Cool. Call by value or call by reference. So either one. Both. You can call by value or you can call by reference for these things. It depends on what you are trying to do. It depends on what you're trying to do. You can do pointer values. You can also reference copies and things like that. So it can be both depending on what you're trying to do. Yo, Mr. Griffin, CM Griffin, welcome. Come on in, everybody. We're not right at the end, but we're slowly approaching there. Not slowly approaching. We're about to do 2 problems really quick. But yes, welcome. It's good to have you all here. Come on in. Shout out to Mr. CM Griffin. We've talked about him a ton on here. Again, if you want to learn how to code better, if you want to work with someone, just chilling, building some cool things, definitely give Mr. I did it again. I always mess up the shout out the first time. Let's see. We're creatures of habit. I fixed it that time. But welcome. Good to have you. Thank you so much for the raid, sir. It's good to see you. I hope you had a great stream. Hope you're having a great day. It's just, phenomenal to be in your presence. I love it. Hope you're having a good night. What's up, Backend Dev? Welcome to the channel. Thank you so much for the follow. What's up, Koijre? Koi Junior E? Koi JR? One of those is right. Raw Code. Welcome to the channel as well. It's good to have all of you here. Dope. It's one the other day made me giggle. Yeah, you gotta just try a bunch of things. Eventually you get it right. Koichiri. Okay. That is better than everything I said. Way better than everything I said, and it makes sense. Okay. Koichiri. Koi is enough. All right. I'm gonna try both. Okay. I'm gonna do my best to remember. I'm gonna do my best. I'm committing it. Hold on. I gotta first give it a see. Gonna make. I've noticed that as I'm closer to becoming a father, I keep wanting to make more and more dad jokes. I was gonna make a get joke, but it was, I still didn't feel good about it because, I still have some time before I'm in full dad joke territory. So I'm glad that I kept away from that. What's up, Lumen? How are you doing? Bring them on. I'm sure they'll come. I'm 100% sure they'll come. All right, need to go post office. Absolutely. I completely understand. Thanks for coming through. Go do what you need to do, especially because I'm sure you were streaming for forever. Appreciate it, Omer. Thanks for coming through. See you later. All right, so let's do this in Python really quick. Let's pass some stuff in here. So let's also do an add function here. Let's switch this up to be an addition function. And again, much like we just did here though, because Python is a dynamically typed language, we do not have to be explicit about types, and we can simply do, hey, num1 and num2, or whatever you want to call it. You can call it whatever you want as long as it's not a reserved keyword, and we can print num1 plus num2. And let's go ahead and call add instead. And 5 plus, actually not 5 plus, just 5 and 9. How about that? And let's run Python 3. Python, what number is this? Oh, 5. And it adds it together and we get 14. So the same thing, you put what you want to take in here, and you're good to go. Dorian, thank you so much for the 10 gifted subs. That's 40 to the channel. That's love right there. That's amazing support. Thank you so much. Please thank your gifter. Again, we got to get some emotes for the war on ads. We also got to get a little stream sound or a little stream gif about the war on ads, because we really are. We're making good headway against those advertisements, making sure no one has to watch them. Thank you so much for the support and the love. And again, please, my heart is warm looking at all these names of people who no longer have to wait 30 seconds to get into the channel. I love it. This is not required to get question and answer. Maybe we'll make it. Maybe we'll make it a requirement. No, not at all. Never will be. And soon, very, very soon, there's going to be very, very soon. We are there. Being full time, being able to have all day to be able to work, broker deals and stuff. There's some cool stuff coming. There's so much going on. I want to announce some of the stuff, but just gonna wait till it gets there, because how things might get put off. Well, I have no idea when this baby's coming, so I have an idea. But, it might. I still got to figure some stuff out, but there's some really cool stuff there. Yes, we got to take down all the ads. That's the goal. There may be a thing soon where everybody always gets a sub. Okay, that's all we're saying. That's all I'm saying right now. Is there may be a time relatively soon where everyone has a sub. So that's all I'm gonna say. That's a piece of this. That's a piece of a surprise. Just a piece of it. A very small piece of a surprise. There's many more surprises as a part of that. All right, cool. So this is how you take in information, and again, you can have more than 2, but you must. If I create 3 of these, if I say, hey, this takes 3 things, but I do not pass in 3 things, it's gonna give me an error. It's gonna say, hey, you're missing one. I can't call this until you have passed in everything that we need to pass in. So yeah, what's up, Duke Nukem? Good to see you. How are you doing? And so that's passing in arguments. The last piece of a function that you need to know after arguments is getting information back. Remember, we said this reusable piece of code is like a little box, okay? Things that go into this box, the stuff that occurs into this box, it stays there. What goes into the box stays into the box, okay? So whatever goes there, whatever the processing that you do, you might say, oh, but we just saw some output. That's because we did a print. That print occurred inside of the function. So it printed from inside of the function, but that data, all that data and stuff is really stuck there. It is, by default, it is not usable outside of that area unless we do something called a return. So when call of a function, we're usually passing in some data to be processed and looking to get some type of output. In order to use the output outside of the scope of that function, we will talk about scope one day, we must return it. We must return that data out of the function. Multiple values can be returned, and I'll show you how to do that really quick. Also, I think someone asked a question a little bit earlier about, can you set a function output to a variable and go? Yes, Dorian. That's what I was waiting until we got to this point here. I was waiting until we got to the return section. 100%. It must be returned though. There must be a value that is returned from the function for you to be able to save that. But yes, you can. Where can we get the file for this lecture? Do an exclamation point slides if you want these slides, and this will go on my GitHub. So if you do exclamation point GitHub, you can just like follow my GitHub or star my GitHub or something, and you will see this repo being updated. There's a deCoded Q1 2021 repository there. You can follow that if you want to get all the code that we're writing afterwards. All right. Can a struct reference be leaked off the stack and go? I don't know. I don't know. That's actually something we may be able to mess around with that. I don't know. Probably the function reference. I'm trying to think. I don't know. We can mess around and try that. Definitely mess around and try that. Return a pointer to a struct. You can yes you can. So yes, you can definitely return a pointer. You mean return a pointer as a value inside one of the parameters of a struct or one of the variables in a struct? Yes, you can definitely do that. If I'm understanding the question, that was declared locally in a function. I don't know. Yeah, you should be able to. I'm pretty sure you can. I'm pretty sure you can. We can, maybe we have some time at the end. We'll check that out. All right, let's see how returns work really quick. The way that you return stuff is with the return keyword. It's simply with a return keyword. So right now, this isn't gonna do anything. So it prints it out, but let's say we actually let's go back to the Go one real quick. Let's say this add function right here. We couldn't use, like, it's printing the value, but it's not doing anything else. So let's say maybe we did this. Let's say maybe in here we were setting a total, and we were setting the total equal to this, and maybe we wanted to get this information. We actually wouldn't be able to return. Let's say maybe we're creating total like this. All right. You may think that you could run add. You might believe you could run add like this. And then maybe you think you can print total. Maybe that's what you think you can do. Because I think that's a reasonable thing to want to do. Because why would you think that? I mean, because you know that if you create a variable and save a value to it, you can use it elsewhere. That's what we've been learning so far. And you might think you can do what we're doing here. Add the numbers together first and then print out the value. And you can already see it's underlining. Whoops. Go. And it says, hey, undefined total. This has to do with scoping. We're going to dive deeper into scoping. But remember, this is a little black box of information, okay? Little black box of information. If we wanted to be able to use total or use this information, we must return it. So instead of saving it to a value, we can simply use the return keyword, and we can return the value of num1 plus num2. But if we return the value, check this out. We can return that value if we'd like. And we can run this code. Come on, save up for me. There we go. We can do that, and we can run this code. And it says, hey, too many arguments to return. So I typed in the return keyword, but I did not fix the function signature to tell it that we're going to return everything. So Go works a little differently. You got to be explicit about what happens. You have to tell it what you're taking in. So I said, hey, I'm taking in num1 and num2. I also have to tell it what I'm returning. All right. I have to tell it what I'm returning. And all you have to do, you don't have to give it a variable. You just have to tell it the type of something that you're returning. So all I'm going to do here is I'm going to type in int. Okay. So this function signature that we are saying here, this function signature says, hey, create a function called add that takes in two variables. Number one, which is an integer. Number two, which is an integer. Return an integer. Okay. I'm returning one thing, and it is an integer. I don't need to give it a name or anything like that. And here I'm returning that value. So I can try to run this, and we can run it. And this is valid code. Great. It's doing this. It's adding them together. This data is getting returned out of this function, but that doesn't mean anything to us because we're not doing anything with that data. We must capture that data. And so I can say, hey, sum or total. I'm going to save that equal to the output of this thing. So it's going to call the function, add them together. This data is going to get returned, and that data is going to get stuck into the total right here. All right. And so now we run it. Total declared but not used. This is again Go because I caught it. So this is still valid code. Well, it's good code. The code is correct, but I didn't use total yet. So I'm going to go ahead and print that out really quick. So I'm going to do format that print line total to make sure that we see what total is. And now we can see this. Why is this stuff not taught in high school or even middle school? Duke Nukem. I 100% agree with you. I think that nowadays, I think some level of computer science should be taught. Just like seriously, just super basics to see what people would might want to get into to pique interest. I just think tech moves so fast, schools couldn't keep up. But I do think it's a super important thing. But I also think they should teach you things like taxes as well instead of. I saw you see the memes all the time. I was like, oh, I'm so glad that I learned a parallelogram instead of taxes in school because my parallelogram is going to come in. It's going to come in huge on a parallelogram day. I get, it's pretty wild. I understand those things are important. All these things are important, but I do agree. I think there needs to be. I personally have pretty strong views about the shift that needs to happen in education, especially particularly in the United States. I don't know how things are elsewhere. I think they may focus on other things elsewhere, but I think one of the issues here is the things that you learn and that you focus on. It needs to shift. I don't have a problem. Like people think I have a problem with. I don't have a problem with traditional education at all. I don't like because education is important, like very important. I think that we're still teaching things in a way that were for the agricultural industrial revolution, and the way that we're teaching things, the stuff that we're teaching, it's just pretty outdated. The methods, all those things. I think the entire thing needs a revamp. If we really want to be able to teach and to have people understand things and to create members of society who can do things, like it definitely needs to evolve. It hasn't evolved at all. It definitely needs to, it's become like a place to babysit people's kids. Not all schools, definitely not all schools, but a lot of places, unfortunately, around the country, that's kind of what it is. And they teachers unfortunately have to teach to exams rather than helping the kids to actually learn stuff. They got to try to teach to make them be able to pass an exam that's of random things. It's pretty wild. It's actually pretty crazy. My dad was an educator for over 30 years and stuff. I got to see some interesting things there. Like my brother was a teacher for a little while. Like, yeah, it's a very interesting thing that it's so weird that it hasn't changed at all. But it's also, I tried to I was super gung ho a couple years ago of I want to help out. I want to see how I can help change some of this stuff. I was like, hey, I was going to go do this in schools. I was like, hey, I'll just come in for free. I'll literally come in for free and teach what I know. Like we can put together a curriculum. I'll just teach what I know to the kids. I'll show up every day. But there's so much red tape. There's so much red tape. You can't, someone can't just help like that. They can't just help like that. And I do understand why. There's so much red tape to being able to do things like that. And hoops, there's so many blockers in being able to do stuff like that, it's tough there's so many organizations out here who are trying to help evolve these things, but it's so hard, so many layers and levels of bureaucracy to be able to do it. It's pretty wild. It's really, really wild. Definitely something that I'm thinking about as, we have a kid on the way. I have a couple years to think about it, but figuring out how to handle this. But yeah. All right. So real quick, 859, what we're going to do now that you know how to take in data and print that stuff out and also get a return output. We can even do that here. Same thing. We can simply return, instead of printing this, it's also returned in Python as well. And we can save this to a value. Or we could just print this out as well, but whatever, we'll say total. And then if we go ahead and we print total, this will work. So we are returning this value outside of the function to be used. And let's rerun that Python thing here. And whoops, it needs 3. Let's remove this. And let's run it. And that also works. Great. Phenomenal. Exciting. So functions, what you need to know about them simply is that they are reusable pieces of code that only run when they're called upon. The way that you call upon them is by name with those parentheses. So when you see parentheses, think functions. The functions can take in data called arguments, and you can pass those in, and you can have as many as you want. You can separate them by commas, and that the data, the things that are processed inside, aren't inherently accessible outside of that function unless you return that data. You can return more than one thing. If I wanted to return, let's say these were variables instead. Let's say I just wanted to take in num1 and num2 and then return them both as 2 separate pieces of data. This is how I can return 2 items, and then I could save those by like total and total one, total 2 or something like this. And I can save these values this way. So you can return a bunch of data as well if you want. All right, let's do our quick triangle thing. So one of the sites that we're going to be working off of and doing some things off of is exorcism.io. It's a great website. I would tell you to type in exclamation point exorcism, but I don't think I ever added it, because if you type in exclamation point exorcism, you've typed in 1 less letter than you need, or 2 less characters than you need to just type it in the browser. So just simply click on it and head over to exorcism.io. If you don't know about it, it's not the best tool for algorithmic challenges, and I actually think it's one of the harder ones to get started with, but it has so many different problems on it and stuff that it's pretty helpful, and you can actually get mentored feedback, which is really cool. You can sign up with it's free, completely free. You can sign up with your GitHub account. Really great. I'm gonna log in really quick. I reset a bunch of my tracks already so that I was starting from the very beginning. But when you get into this, you can go to this now. I wouldn't sweat it. We're gonna run through really quick, just one or two of the problems really fast. Like, it's gonna be really quickly. And it's gonna basically use the tools that we've been learning over the last week to be able, well, really the last 2 weeks, to be able to, or 3 weeks actually, to be able to solve a problem really quick. But yeah, do you have a master's? No, I don't even have a bachelor's, but I did go to, so I don't have a bachelor's, but I want to be clear, completely upfront. I do have, I'm like 8 credits short of a bachelor. So I did go to school for a while. I went to school for 5 years, for 4.5, 5 years, to get in pursuit of a bachelor's. I didn't finish, almost purely because of work and cost. I mean, I got it. I was on scholarship, and I did what I was supposed to do while I was on scholarship. And unfortunately, when I got a job after my 4 years were up, and I hadn't finished school yet. I had 1 more year left. I got a job. It was really far away, and I tried to make it work. The first semester, it like kind of worked, but not really. And then the second semester, it really didn't work, and I ended up dropping all my classes. And I was like, okay, I'll go back the next semester, and I just never did, because it cost so much. It was in state, and I was like, man, it just cost too much, to be honest. And I never finished. Yeah, it's like, so yes, Brandon JC, this is it's like LeetCode, but I think the problems are a lot simpler. And I think the goal of this more so is learning than it's more about the learning is more important than the actually solving the problem here. I think that's what I like about it a little bit. But yeah. You should be teaching, my friend. I mean, hey, if me trying to run my own business never works out, sure, maybe I'll go teach. To me, this is being a teacher. I don't think I would want to. So I don't think I would ever want to work in academia. And again, nothing against that. I don't think that's the place for me personally. I think not being able to have the structure over what's taught. I interact with professors all the time. To be honest, I've actually I'm interfacing with a bunch of professors right now about some of these things, and like what happens is it's hard to go through the process of teaching, especially in that space when that's your job. There becomes a big disconnect between the industry and the information. It becomes a huge disconnect between those things, and I think I don't know. I think it's a little bit more important in this space, in the tech space, to have a much better handle on those things. And so I actually think that's a big part of where maybe Mastermind comes in. It's kind of bridging that gap, even between all the other educators and what's going on in the industry and what people are actually doing. Is probably something that I think is important. But once you get into this, you can click on a language track. Click on whatever language track you want, to be honest. You can try a bunch of different things if you want. I'm gonna hop into the Go one. These so each language has a subset of problems that are the same amongst all the tracks, or as many as could be applied to each track. And so you'll see these over and over again in different languages. But we're gonna grab one. Was it conditionals? Triangle. We're gonna grab one called triangle, okay? And don't worry about getting all set up with this right now. If you've never done anything like this before, There's a getting started where you have to get this set up to be working on your computer. I'm not actually gonna do this exact problem. The reason why I'm not gonna do this exact problem is because they've implemented the way that you solve these. They've implemented a test-driven development strategy to these things, and that's a whole nother thing that we need to talk about to do this. We're just gonna read it, and we're gonna implement our own solution of it really quick. Okay, so we're gonna say, hey, determine if a triangle is equilateral, isosceles, or scalene. All right, so take it on back to 8th grade geometry class, maybe earlier. I don't know when people learn geometry. I have no idea when I learned geometry. 8th grade just felt like the right grade to stick in there. All right, an equilateral triangle has all 3 sides of the same length. So equilateral makes sense, equal, okay? An isosceles triangle has at least 2 sides the same length. All right, that's a weird thing to say to me, that at least 2 of the sides must be the same, because if the third is the same, that feels like it's an equilateral, unless this indicates that an equilateral, okay, that's not important to the problem, but okay. The 2 sides are the same, all right, on an isosceles. So equilateral, all 3 the same. Isosceles, 2 sides the same. And I guess a scaling triangle has all sides of different lengths. For a shape to be a triangle at all, the side must have a length of greater than 0. And the sum of the lengths of any 2 sides. So if you add up 2 sides, it must be greater than or equal to the length of the third side. Okay. This is very interesting. I didn't realize there was this much in this problem. But that's not a big deal. See, triangle inequality. Very, very cool. Okay. Dig deeper. We can go through all of this other stuff. So we need to figure out, I am going to download this actually. I'm going to download this. I don't think I have this set up. No, I'm not, because I don't want to do all that. So we need to be able to, no, I lied to you. I'm going to download this. I'm going to click begin walkthrough really quick. This is going to take a zip file, walk through it on, like seriously walk through it on your own time. I'm going to run through it really quick so that we can get the code and we can walk through this. The reason why I'm going to do this is because it's going to give us a bunch of test cases. It's going to give us some things to test out, and I do want to test those things out. So I'm going to grab, what am I using? Am I using Ubuntu? I think I'm using Ubuntu. So I think I can just use the simple Linux x64 one right here. We'll copy link address. How you doing, Hellraiser? Good to have you. What's up, Young Guns Junior Professional? Sauce Cat, welcome to the channel as well. Morph is Vicious. Akmasi, OC Masi, how you doing? Welcome to the channel, everybody. All right. Actually, I take that back. We're not going to do this one. The only reason we're not going to do this one is because I think there are a number of steps in here that I think me running through quickly are going to confuse you. Let's fizz buzz it up. Let's learn the infamous fizz buzz, and then we can do something like this next time and start to dive into some more of these. So let's fizz buzz it up. We always do fizz buzz at this point in this course, and so you're going to learn how to do fizz buzz. Fizz buzz is it's kind of a meme in the industry, to be honest. It's funny because it's actually a problem that a lot of people don't know how to do. A surprising amount of people don't know how to do a FizzBuzz style program, but we will do it right now really quick, just to so you can start to see what's going on here. I was gonna do this. No, we're gonna do it with Go. We are gonna do it with Go. I want you to get more and more comfortable looking at code like Go. So Vim FizzBuzz.py. Not Vim. We want code. Gotta get rid of this muscle memory and think about what I'm doing. So FizzBuzz is what we're gonna do. So I'm gonna set up, I'm gonna set this up and I'll tell you what FizzBuzz is. Whoa. Oh, I called it something wrong. It is not supposed to be that. It is supposed to be move FizzBuzz. Oh, I never saved it, so that's good. So don't save it. co-r.go and not py. All right, so let's set up our application really quick, and we are gonna run through this. Set it up, func, main. All right, so here's what it is. I'm gonna put a little thing here. FizzBuzz says this. It says for numbers 0 to 100. It's usually 1 to 100. I'm gonna put 0 to 100 just to save a little bit of time here. 0 to 100. So comma, print each number is what we want to do. Okay. We want to print numbers. That's where we want to start. And it says, so print out the number 0 to 100. But for each number that is divisible by 3, print Fizz. So instead of printing the number, we print Fizz instead of the number. Okay. For each number, let's take this. Whoa. Click this, yank it, paste it. For each number that is divisible by 5, we are going to print Buzz. Okay. And then the last one is for each number that is divisible by 3 and 5. What? Go ahead and print Fizz Buzz. All right. This is the infamous Fizz Buzz program. If you ever heard of it, this is the infamous Fizz Buzz program. And all we're going to do is implement this really fast. So this is great. This is going to utilize everything that we've learned so far. So first things first, we need to be able to count to 100. And so we can go ahead and we can do that. All right. So let's make sure we get that done. How can we do that? Well, let's go. Let's use our for loop. Let's create a for loop here. And we can say for I equals 0. So we're going to start at 0. While I is less than or equal to 100. Okay, that's when we want this for loop to run. That's the scenario we want it to run. As long as I is less than 100, we want this thing to run. And then every time it's done, we want to add 1 to I. Okay, so that's going to set up our scenario to do that. And I'm going to go ahead and do format.println I, just to make sure that we are printing to 100. Let's just make sure we got it right. Make sure we got some code here. So go run fizzbuzz.go, and we get 0 to 100. Okay, pretty easy. Let's see, a clip by Fizzbuzz. Who's it? Let me see. Let me pull this up. Oh, this looks like it's about to be a tough Fizzbuzz. Okay, I'm gonna save that. I really want to watch that. But cool. We're counting this from 0 to 100 right now. Phenomenal, excellent, good to go. What we're gonna do now is we need to implement these things. So we're gonna say for each number that is divisible by 3. Okay. So we're gonna do that real quick. But how do we know if a number is divisible by 3? So we can divide it by 3. We know how to do division. We learned arithmetic operators. We know how to divide. How do we know if it's divisible by 3? Well, something that is divisible by 3 must have a remainder of 0. So if I divide 3 by 3, we get 1, but we get a remainder of 0. What can we learn? What do we have that we can use for this? And that is modulo. Okay. So now we can start to put together some of the things that we know. So conditional flow, we can start using if statements. So we can say if the current number that we're on, which is I at any given time, is I modulo 3. Okay, so we're going to divide that number by 3. All right, we'll say if this number is divisible by 3, but not even if it's divisible by 3. This doesn't say anything. This just says if divided by 3. This is actually not going to give us a true or false. We got to make it a Boolean value. How do you make it how do you get back a Boolean? You need to do some type of comparison operator or equality operator or whatever. And we're going to say if I modulo 3 equals 0. Okay, that will tell if it's evenly divisible by something. If it's 0, that's when we're going to go ahead and we are going to format.print Fizz. Print line. We will go ahead and print Fizz. Okay, so now I'm gonna go ahead and I'm actually gonna run this and check this out. We get 0, 1, 2, 3. Okay, that's oh wait, am I past? Oh, I'm past it. Never mind. I was like, that seems weird. So we get is to start, then we get 0, 1, 2 is. Then we get 3, 4, 5 is, 6, 7, 8 is. So it looks like it's supposed to be, it looks like it's printing out at the right space. It looks like it's printing out 1, 2, 3 is where we're supposed to print Fizz, but it's still printing out the number 3. Why is it doing that? And then we get 4, 5 and then Fizz, so it's at the right place where 6 is supposed to be, but we are still printing out 6. The reason why is because here we are printing out the number no matter what. So if the if statement is right, it's printing this out, and then it's still finishing this part, and it's going down here. There are two ways to solve this. You could actually do a continue here. I could actually solve it like this. This is not the best way to do it. I'm just telling you that right up front. You could solve it like this. All right, and if I run this again, I get 1, 2, Fizz, 4, 5, Fizz, 10, 11, 7, 8, Fizz. So instead of the number, I'm printing this out. You could do this. This works. This works. But there's an easier way to do this in a little bit cleaner way than having to do this. And the cleaner way is to simply, instead of doing this, we want it to print out either Fizz or the number. So in this if statement, we can add an else in here, okay? We can say else, and then take this print line and stick it in the else. And so basically, those are the only two options that are a part of this logic operator. Either it will print Fizz or it will print the number. It'll either match this case, and if it doesn't match this case, then it will do this. This will stop it from doubling up on numbers as well. And if we print that, you can see here, 88, 89, Fizz, 91, 92, Fizz. So it's helpful. It's not also printing out the number as well. So now that we know how to check for 3, how do we check for 5? Same thing, okay? So we can take that and we can paste it here. But we learned that we can only, we can only have one if. So we can do an else if here and say else if it's divisible by 5, print out buzz. All right, so it's doing a couple things. It's checking here. If it's divisible by 3, printing out Fizz. If it's divisible by 5 instead, it's going to print buzz. And if it's not either one of those things, it's going to print out the number. So we run this and let's look to see if it's working right. So we get 1, 2 Fizz because 3 is divisible by 3, 4, 5 Fizz, 7, 8 Fizz. Okay, interesting. We're not getting any buzzes here. Or did I go too high? I went up too high. I scrolled too high because the scroll wheel is very sensitive. All right, so 1, 2 Fizz, 4 buzz, Fizz, 7, 8. All right, so it looks like we're getting both. It looks like we're getting Fizzes and buzzes. And we should be getting on the buzzes on the 5s and the 10s. So 80 should be buzz, 85 should be buzz, 90 should be buzz. Oh, 90 should 90 be buzz? Or 90 is also divisible by 3. Okay, so that's actually Fizz. So that's what the last thing is supposed to catch. The last thing is if it's divisible by both. All right, and so you could do this in one of two ways. All right, for time's sake, I'm going to do it in the right way first, but we learned how to check for 2 different cases, 2 different scenarios. So we could take this. Actually, let's do this. Let's yank this and let's put this here and let's do an else if again and say else if I mod 3 is equal to 0. And you can do an ampersand to create another scenario, and I modulo 5 is equal to 0. Okay, so you could do this and instead print FizzBuzz. All right, so you could run this. And so let's run this. Let's take up all of this space. And we just ran it. And if you look closely, we don't get a single FizzBuzz. And I'm doing this to drive home a point about if statements. We don't get actually any FizzBuzzes. We only get Fizzes and we only get buzzes. The reason why is because every number that's divisible by 3 and by 5 means it is hitting one of these statements first. An if statement block will only hit, it'll match the first case it gets to. It'll match the very first one that makes sense. And as soon as it makes sense, it's done. It'll go to this for loop. It'll send it off to the next iteration. Okay. So it's going to match the very first one that matters. So you actually you'll never get down here. You never get down to this. So there are 2 ways to handle this. The first way is changing the ordering of the way these things work. So you can solve these by instead taking this right here. Oh, oops, undo. You can take this and you can put it up here. And make the very first statement that one. And you can do 3 and you can do 5 here. Let's actually, you could do it like this. And then you'll get some weird stuff. But it will mostly work. Hold on, let's see. So you could do it like this. This is an acceptable solution. This would cause your code to not print out FizzBuzz at all because we didn't change out what it printed. Hold on. We didn't change out the actual thing that it printed. So this does work. This works. It is a valid solution to your problem. Okay, so we get 1, 2, Fizz, 4, Buzz, Fizz, 7, 8, Fizz, Buzz, 11, Fizz, 13, 14, Fizz, Buzz. Notice where Fizz Buzz is, okay? We get our first Fizz Buzz at 15, okay? Is 15 divisible by 3? Yes, it is. It equals 5. Is it divisible by 5? Yes, it is. It equals 3. So this will work. This scenario does work. It's great. An easier scenario is we can actually do something else. If a number is divisible by both 5 and both 3, we can find the least common denominator, and the least common number that goes into these things, the very first number that we get to is 15. So the lowest number that anything that's divisible by 3 and 5 is also divisible by 15. And so we can actually just multiply those two things together, and our first statement can actually simply be checking if I mod 15, little hack here for you. If I modulo 15 equals 0, then it is Fizz Buzz. And so what that'll do is that'll do the exact same thing and you will get Fizz Buzz, because that's the way math works. And so we have our first little iteration of a Fizz Buzz style program. We have our first iteration of a program where we had a clear goal and we had to go into it and implement different scenarios. We had to change the flow of the program based on what was happening. We're counting to 100. We're taking that number. We're determining whether or not code should run and which one runs. And so this is really cool here, and you can do this. But yes, you can keep the two conditionals. There's a bunch of different ways to play around with this. I should check it. I may need to switch to 3 and the 5, but yeah. You can also do fancier implementations of this. People have done all kinds of wild things with implementations of this. This is kind of the standard bare bones implementation of FizzBuzz. There are probably some cool tools in both languages, Python and Go, that you can do. I've given you this. I highly encourage you to try to take this in, even if you don't understand logically what we did, you can see the code. And I would encourage you to try to take it and maybe transition it over to Python. Just to kind of, see if you can make that mapping. It is very much the same. You need to write a for loop that counts to 100 in any way that you can. And then you can follow the same flow, the same logic, okay? Can you do single line stuff in Go? Yes, but no. So not in the same way, that you can do cool stuff like that in Python, like list comprehensions and stuff. Not really. But there are ways in Go to optimize this a little bit. Can you quickly translate the first line of the for statement? Yep. Again, let me where's the pen? Yes, 100%, because this is 100% one of the most confusing things in the world. What this line is we draw it on the other one, but I'll make another one because it makes a little more sense in the statement. What it does is it sets up a for loop. It's going to run over and over again. The first thing that happens is it sets up an incrementer. So it sets up a way for us to track. You set up a way for us to track how many times or what's going on in this loop. So I don't know how to change the color there. It's the incrementer, okay? So we're setting up a number so that we can start to track what's going on. And so we started at 0. The second piece here is the is our statement of truth. This is the scenario that's going to be evaluated. So this is what's going to determine whether or not it runs. It's going to evaluate whether or not I is less than or equal to 100. If it is, the code will run, and it will continuously evaluate this until this statement is no longer true. That's when the code will stop. That's when this loop will stop running. And then this is what happens after each run. So every time all this down here runs, this will happen. And this is called, actually, this is the incrementer. And it increments this by 1. This is the iterator, not the incrementer, I'm sorry. This is the iterator. It's a number to track iterations, the amount of times the loop has gone through, and the incrementer is at the end, and it basically increments by 1. What the I++ says, hey, add 1 to I. I is over here. So after the very first run, it'll run this little incrementer part, and I will now be 1. Okay? Yeah. So that's what we'll have. And yeah, I'll put this in the Google Classroom, and I'll also add in a number of I'll add in so I have a video of someone else going through these loops, which can be pretty helpful as well. But cool. Hopefully it says we had a lot of conversation. That's really good. I gotta get out of here because I gotta go eat. But I'm going to add this, and some other stuff is going to drop. Like I said, you have I think you'll have 1 assignment this week. So I'm also going to push a fix for the first one. So if you already did the first GitHub assignment, it'll automatically update and let you know if it was correct or not. And there will be another one dropping, a little bit more difficult one dropping. So I might even add in that isosceles triangle one, the equilateral and all that other stuff. I might actually add that in as our own assignment to try to work through, because it seems pretty interesting. But yeah, that's it for tonight. That is it. So real quick, tangible takeaway for the evening. What did we learn? We learned 2 things. We learned loops and we learned functions, which you really need to know. At the end of the day, you don't need to know all the syntax, all this other stuff. You'll get there. What you need to know is that a loop is how you run code multiple times over and over again. The code will run as long as a scenario that you create is true. So when we say true, you should be thinking Boolean values. So we need to create a scenario that evaluates as true or false. And we can use those comparison operators, those equality operators to make a statement like that. And so we set a scenario, figure out if it's true or false. If it's true, it'll run the code underneath, and the loop will continue to run as long as that scenario is true. We learned that we may need to use something like an iterator. We may need to create some type of variable to track this and to update while our code is running, so we know either how many times it's gone through, or so that we can indicate when this loop is to stop. We need a way to change the scenario so that eventually the loop stops. We learned that we also have some other control flow things in there. We learned that we have the break statement, which will break out of a loop. As soon as it hits that, it'll end all iterations of the loop. And we learned about continue, and continue, if we should put continue in there, it will exit the current iteration of the loop, but it will continue on to the next iteration. So if we want to skip something, that's the best time to use continue and move on. But we don't want the loop to end. We learned about the continue a keyword as well. We also learned that there's while loops and for loops, and when to use those, when you can use those. We learned about functions, that really those are little reusable pieces of code that only run when called, so they won't run unless you call on them. In parentheses, we also learned that you can pass things into them called arguments or parameters. Sometimes you can also get data out of them by returning that data as well. And we also just did a quick little FizzBuzz thing here, implementation of FizzBuzz in Go. This is, again, the most bare bones implementation. This is usually good enough. This is usually what people are looking for if they should ever ask you how to do this. I would also say, be wary. FizzBuzz is a dumb thing to be asking people to do on an interview. So if you ever get asked FizzBuzz, one, it's helpful to know it, because it's right up front, it may seem confusing, but it's actually a pretty simple problem once you kind of dove into more of the ways to learn how to think like a developer. But I probably would never work at anywhere that asked me seriously asked me to write FizzBuzz as a challenge. I think it's dumb. I don't think it really tests. I don't think it really, I mean, if that's your goal, to like test someone's acuity, I'm not sure that does a good job. but I also have a lot of gripes about the interview process anyway, in tech. So I don't know. But yeah, hopefully you got something out of that. I'm gonna push this code right now so that you have it. Oh yeah, stuff we did yesterday. Did I not push this? -m decoded, not decoded, functions, loops, and fizz buzz. And now you can all grab this. I have expect you to say, if they ask you to write fizz buzz, laugh and walk out. I mean, I don't want to tell you that, but it's a weird thing. But I also think most of the coding challenges and things that they give you are really odd. And they give you just random coding challenges that, like, one that half the time people in the company can't solve, but has nothing to do with the job that you're going to be doing. That like it's not even testing similar like foundational concepts that you're going to be needing to do the stuff that you do. Like, I mean, I don't know, man. I understand, but I also don't understand. Make your solution so complex they won't understand the code. 100%. If it works, it works. Make it so complex they don't understand it. Seems super weird, but you know, we're also the same way. I have a war on advertisements. You know, I don't have a war on my own advertisements. So again, when you all have companies out there who would like to be stream sponsors and want a little advertisement, you know, we can throw it in there with some cool segues and things like that. But unskippable ads are trash. And you know, we got the same way we have a war on those. I have a war on dumb coding challenges or dumb interview questions, period, that just are like, I think it's dumb for you to be looking for someone who can do work for you that's going to make you money, and the way that you try to get them is to stump them. Like, I don't understand. Like, I don't get it. I really don't get it. Like, I don't think it like I don't think stumping someone proves that they know things. I think giving them a chance to prove what they know shows you that they know things. I don't know. I feel it's dumb. It's why would I try to stump you? It doesn't make any sense. It really doesn't make any sense. But I don't know. Unless you have some super specifics, I think it's okay to ask things that are pertinent to what you're doing. Just know, like, people just ask random stuff. Like, I don't know. I feel strongly about it. But cool. That's it for tonight. Let's head over and raise somebody. Thanks everyone for coming through. That is so for you all. You have some stuff coming, but that is week 3. You're 3 weeks down. You know, we got 5 weeks left. You know, we're getting there. We're slowly building, and you can see how the concepts kind of really picked up. And once we got into the logic section, I got a little farther along. I think we're about to go into algorithms, and like starting to do some algorithms next week. Is that what we're doing? Let me check. Let me confirm really quick. But I think we're gonna start to be able to implement this stuff in a more practical way. Like tonight, we just kind of ran through some things, but we understanding loops. Oh, actually, so this was actually. Oh yeah, I had to move this in here because it didn't make any sense for us to do this way. Yes, that's what's happening. We're actually going to be moving all of this up to here. I forgot to update this. We're moving this up, so we dove into loops now. But I thought it was more important, instead of spending a week going through loop problems, I thought it was going to be better to get scope and everything all together. And then we are going to actually spend these 2 weeks diving into some very specific problems. So we're going to start to learn how to solve problems, start to learn how to tackle problems, and then we'll get into the deeper like algorithmic problem sets. We're going to end up doing this stuff. So it is shifted around a bit. I will send a message in Classroom when I update this, because it is different now. It's actually more. It's more. You're getting more now than you were getting before, to be honest. So if you were following this and thinking we weren't doing this in week 4, there you go. I forgot I never updated this, so I'll update it. But we have some cool stuff. We'll start implementing code a lot more starting next week. I'm probably going to start also adding along, what are those things called? Notion pages, so that you can copy and paste some specific sections of code and stuff. I'll probably also start providing some stub code as well to make things a little bit easier as we're going through. So that we can focus on the concepts rather than syntax of getting the file set up and everything like that. we can kind of just go and be great. But cool. Who are we heading over to raid today? Let's see who's online. Anyone new? Let's find somebody brand new that we've never seen before. Even though I want to raid the Alt F4 because Atoda is actually on there learning TypeScript. But let's go viewers lowest to high, and let's go up to like someone with like 5 or 6 viewers. Oh wow, there's a lot of people on. Surprising amount of people on. Let's go to Queen Respect, Queen of Coding in PHP. I'm not a PHP lover, but coding is coding. Let's head over to the Queen of PHP. Say hello. Hopefully this makes this person's day, and hopefully we don't freak them out too much. But let's go over and say hi. So for all smart people in the world, is Steam OS worth using? Duke Nukem, if it's big picture mode and you're using it on a TV, I think so. But that's it. That's the only time I would use it. But cool, let's head over and say hello. I don't know anything about this person, so if we get there and they cuss us out, it'll be funny and something we can talk about in the future, but I did not know it was gonna happen. Let's see. And we're gonna head over in 10.9.8.7.6. I'm not even gonna hit the FX button because obviously that causes me lots of problems. 6, 5, 4, 3, 2, 1. Peace out, everyone. Have a great night. I'll see you tomorrow if you want to learn anything about cloud computing. And we do have office hours this Saturday as well. So see you later. Thank you all.